Бачу, що вже всі зібралися, тому ми розпочинаємо. Сподіваюся, що сьогодні буде так само цікаво і корисно, і багато нової інформації для нас, як це було на попередніх. І так, у нас сьогодні розпочинає вебінар Даніель Джак, EU Support Group to Ukraine. Даніель, you are welcome.
Yes, доброго ранка. Good morning once again, everybody. Good to have you online. And indeed, I represent the support group for Ukraine, calling here from Brussels. And I would like to tell you a few words about basically what the EU is doing in terms of transport modernization and greening of transport, and also about our cooperation with Ukraine. So first, regarding the context, you will know that the European Green Deal calls for 90% reduction in greenhouse gas emissions from transport by 2050. And the objective here is to help the EU to become the first climate neutral continent. This is important because currently the green transport represents about 1/4 of the total greenhouse gas emissions in the EU, and this share has been continuously growing over the last decades. And hence the adoption by the Commission of the Sustainable and Smart Transport Strategy in December 2020. So it's pretty new. We also know that the transport was amongst the sectors that were hardest hit by the coronavirus pandemic. And we believe that in this context, we need to continue to work on the future of our European transport system so that it can quickly recover from the severe impact of this crisis, and to do more regarding reforms, policies, and actions to support the sector. So the objective is to make the European transport system more sustainable, smart, and resilient. And for that purpose, we have set a number of milestones by 2030. I will go maybe quickly through them. We want to have at minimum 30 million zero-emission cars and 80,000 zero-emission lorries in operation. We aim to have at a minimum 100 climate neutral cities. We think that scheduled collective travel under 500 kilometers should be carbon neutral within the EU. We want to have doubled high-speed rail traffic and increase also rail freight traffic by 50%. We want to increase transport by inland waterways and short sea shipping by 25%. We want rail and waterborne-based intermodal transport to be able to compete on an equal footing with road-only transport in the EU. We want to develop paperless freight transport, automated mobility, integrated electronic ticketing, and have operational multimodal trans-European transport network equipped for sustainable and smart transport with high-speed connectivity on the so-called trans-European networks. And finally, zero-emission ocean-going vessels that would be ready for the market. So we have also further milestones for 2050, but maybe I will not go into details at this stage. But to make things short, basically what we want to achieve is an irreversible shift to zero-emission mobility, making all transport modes more sustainable, making sustainable alternatives widely available in the multimodal transport system, and obviously putting in place the right incentives to drive the transition. And for that, we want to achieve a seamless, safe, and efficient connectivity, reinforce the single market, and also an important dimension for Ukraine, we want the EU to be a world's connectivity hub by ensuring undistorted international competition and a so-called level playing field. We want to deal our transport relations with our partners, and we want to promote global climate action. So this is, I would say, for for this strategy that the EU is now starting to implement. Coming more specifically to our EU-Ukraine transport cooperation that we believe we can reinforce in this context, I would say that the overarching instrument is the EU-Ukraine Association Agreement, as you will know. And basically, we aim at ensuring that Ukraine has a modern, efficient, safe, and obviously sustainable transport system. So for that purpose, we are acting on different strands. The first one, a very important one, is regulatory convergence. Basically, we have 48 pieces of legislation, even if we put aside aviation. We have 48 pieces of legislation, EU legislation, that need to be approximated in the Ukrainian legislation. And this goes through, well, first the National Transport Strategy, which has been adopted in Ukraine, but we still expect the adoption of the action plan, and we are obviously supporting Ukraine in that endeavor. And we are also posturing and helping Ukraine in the sectoral reforms. So in that context, I would mention the recent adoption of the law on inland waterways, which should be obviously completed by important bylaws and secondary legislation, but that will be instrumental in revitalizing this important and environmentally friendly mode of transport. And I could name also a number of other laws that are, for the time being, still pending in the parliament and that we hope will be adopted in a very near future. I could just name rail and multimodal transport, just to name a few. And obviously, this whole legislative framework is very important to attract investment, both public and private. And this is actually the second strand of our cooperation, the development of infrastructure. I mentioned inland waterways, but we have a number of projects also on rail connectivity. And we want to develop the corridor. I mentioned the Trans-European networks. You might be aware that we have extended these networks as indicative to Ukraine. And obviously, we want them to be complemented for the so-called core network, which are the main corridors by 2030. And for the comprehensive one, which are I would say, maybe less important axes, these should be complemented by 2050. And we are helping Ukraine in that context to develop these corridors that encompass, well, rail, road, but also ports, airports. And I would say also that one new element is that we would like to develop so-called digital corridors, as we consider that digitalization will be important in greening transport in the future. And then another strand of important actions are at local level. So I think it is important to stress that as well. We have a number of projects aimed at improving urban transport. We have projects related to road safety in an urban context, which shall make transport and also for pedestrians and cyclists more attractive, and that shall protect these vulnerable users. And in that context, we will also help Ukrainian cities to set up so-called sustainable urban mobility plans that we believe are important to strive this action. So voila, just to give you a brief overview of the situation and what we are doing, and just to stress also that in this context, the EU is providing assistance and will continue providing assistance, both in a bilateral context, but also in a regional context of the Eastern Partnership to Ukraine. And I think we have a lot to achieve together. Many thanks.
Okay, thank you, Daniel. It's actually huge and enormous plans, and we hope we will together achieve these plans in time. Thank you. And the next speaker is Andreas Biermann, UNDP. Hello, Andreas. Do you hear us?
Oh, yes, very well. Thank you. Good morning. Can you hear me?
Yes, it's okay.
Awesome.
Great.
Very good. Well, so thank you very much, everybody, for attending this this webinar, which is very important in terms of identifying the challenges and solutions to the climate adaptation threat that is being posed to the infrastructure of Ukraine. I'd like to first thank Daniel for his very comprehensive introduction that provided a really good overview of the EU policy directions, and I think they are really quite advanced, so there's a lot that can be learned from that. We'll have speakers from the Ministry of Environmental Protection and Infrastructure, Mikhailo Chizenko and Natalia Olynyk, from EU for Climate, and from the EU, again, Kyriakos Tenas, and then some experts from the University of Birmingham, Dr. Andrew Quinn, the Rijkswaterstaat Water and Environment Agency from the Netherlands, Kees van Muiswinkel, Eurocontrol on airports, and finally, something that's very close to my heart, Irina Bondarenko and Bogdan Lepiavko, who will talk to us about cycling and micromobility. The core challenge that we face is, I think, in Ukraine, and I said that at the energy webinar, so apologies for repeating this, is that Ukraine is not generally seen as a country that is facing severe threats from climate change. And in fairness, they are probably lower than they are, for example, in a number of sub-Saharan Africa countries or in the Pacific Islands, but nevertheless, they are there and they need to be addressed in order to make sure that the infrastructure of Ukraine is future-proof and can cope with the impact of climate change. So in this regard, it's really welcome that this project is looking at undertaking sectoral climate vulnerability assessments, improvements to hydrometeorological data to understand climate impacts, and developing better climate models for Ukraine that will then feed through in turn into the planning for infrastructure investments. And that we try to get an all-encompassing view that really will lead to actionable outcomes at the project level. So if you do not understand a threat, if you don't have data, then you cannot mitigate it, you cannot manage it, and this is really still the stage that we are at in Ukraine, I feel. So there is particular vulnerability in terms of infrastructure. Heat waves can lead to larger or higher incidences of forest fires. They will threaten infrastructure, roads, power lines. There are elements where we need to look at how we are going to manage, for example, flood risk through higher levels of rainfall on critical infrastructure parts so that they don't become blocked on a regular basis or damaged. And overall, I think there's a need to upgrade technical capacity of Ukraine and really make larger efforts towards formulating an integrated and evidence-based response at sector level. And so this is the purpose of this series of workshops. And today's workshop is on infrastructure, and it's a critical topic. So I very much look forward to learning from all of you about what can be done differently in Ukraine in order to be able to cope with the impacts of climate change that are now probably and unfortunately inevitable. So thank you very much. I wish you all a good workshop and look forward to your participation. Thank you.
Okay, thank you, Andreas, very much. Very substantial as usual. And the next speaker, шановні учасники, я хотіла нагадати, раптом ще хтось не знає, хтось може приєднався до нас вперше, що внизу екрану є переклад. Ви бачите опцію переклад. Ви можете там вибрати мову, якою вам зручно слухати. І наступний наш спікер, наша постійна учасниця вебінарів і наш шикарний викладач Ефрат. Ефрат, do you hear us? Hello, Efrat?
Yes, absolutely.
Hello.
Hello, good day, good afternoon.
Okay, it's nice to see you. Sunny as usual. Yeah, so tell us please about the webinar setup and objectives for today.
The general webinar or my section of it?
No, maybe the general part and the part concerning transport sector for today.
Okay, so we are part of the discussion today is a more specific focus on the adaptation issue facing the different sectors. We are trying to, at least for the priority sectors, to identify some background information that could help the sectors and the various technical experts start to develop the Ukrainian adaptation plans for that sector. And we're hoping that we're providing sufficient information to get you to think about new ways to consider new processes, new analyses, and things that could be improved within your sector, so that you can, as you develop the adaptation plan, you can start integrating it or considering how some of this information could be integrated or improved or made much more Ukrainian specific. That's the purpose in general of these workshops. And today we're focusing on infrastructure and transportation, mostly on transportation, but also some background on other infrastructures, on some things that are joint with transportation, so that we can provide a bit of background on some of the civil engineering and public works approaches that are happening. So I hope you enjoy it.
Okay, thank you, Efrat. And we will see you soon, I hope so. І наступний доповідач у нас Міністерство довкілля природних ресурсів Михайло Чиженко. Ви з нами?
Так, я з вами. Доброго дня.
Доброго дня.
Завжди дуже приємно виступати після Ефрат. Вона як сонечко просто з'являється на екрані, піднімає настрій. До речі, хочу сказати, що так співпало, що коли вона почала виступи, у нас тут на Солом'янці з'явилося сонце, ярко світить і, знову ж таки, настрій краще. Якщо більш серйозно до теми сьогоднішнього вебінару, це вже 4-й вебінар. Ще буде, окрім цього, 3. Сьогодні у нас головна тема – це транспорт і інфраструктура, і, ну, скоріш за все, головне, все ж таки, більше уваги буде приділено транспорту. Хотів би нагадати присутнім учасникам, що наразі у нас в Україні була розроблена і прийнята декілька років назад стратегія транспортна. І хочу сказати, що на той момент мета щодо скорочення парникових газів, яка була визначена цим документом, була, мабуть, найбільш амбітною. Ну, більш амбітною, ніж навіть на національному рівні. 40% від рівня 90-го року. Неперевищення викидів. Наразі в рамках проєкту EU for Climate, який, до речі, і організував ці вебінари, окрім головного завдання з адаптації, а саме підготовки проєкту стратегії адаптації, а також плану заходів на її реалізацію, є 2 дуже важливих завдання або напрямки, над якими ми також працюємо. Ну, перше, це хотів би, можливо, сказати, чи знаєте, навіть присутні чи ні, заплановано і приступили спільно разом з Міністерством інфраструктури до розробки стратегії розвитку велосипедного транспорту в Україні. Можливо, це буде, знову ж таки, доповненням, частиною вже існуючої стратегії транспортної, можливо, окремим документом, життя покаже. Ну, і знову ж таки, в рамках цього проєкту EU for Climate, наразі ми запустили таке дослідження, яке називається «Розрахунок викидів парникових і забруднюючих речовин від автомобільного транспорту за європейською програмою КОПЕРТ». Тобто транспорт у нас в фокусі уваги, і я сподіваюся, що сьогоднішній семінар додасть більше інформації і буде таким же цікавим і для учасників, як і попередні. Тому ще раз вітаю від імені Міністерства усіх присутніх і бажаю сьогоднішнього дуже плідної розмови, і семінару і успіхів усім. Дякую.
Дякую вам, Михайло. І наш наступний доповідач транспортно-інфраструктурний сектор в Україні Наталія Олійник. Наталію, ви нас чуєте?
Так, я вас чую. Як мене чути?
Так, добре чути. Бачимо
Чудово.
вас, чуємо. Раді вітати вас на вебінарі.
Рада вітати. Дуже дякую за запрошення на сьогоднішній вебінар. Це для нас дуже важливо. Хотілося б подякувати і організаторам, і міжнародним експертам за таку ініціативу виділення окремого блоку для транспорту та інфраструктури. Це для нас справді дуже важливим є фактором. Теж хотілося б подякувати, тому що Міністерство інфраструктури завжди долучається до таких ініціатив у зв'язку з спільним напрямком зменшення негативного впливу на навколишнє середовище, що є на сьогодні дуже важливим питанням. Адже у боротьбі зі зміною клімату та адаптації дуже важливим є саме спільна робота, спільний напрямок руху, як і державних органів, так і бізнесу, зокрема. Тому на сьогодні хотілося б побажати всім активного вебінару, цікавого, гарного настрою, і щоб наша спільна робота сьогодні була дуже продуктивною. Як уже попередні доповідачі практично розповіли глобально і концептуально всю ідею, яку я хотіла сьогодні розкрити, і Даніель, дуже дякую йому особливо, розповів про напрямки і цілі у Європейському зеленому курсі, про національну транспортну стратегію, її напрямки, а також про прийнятий закон про ВВШ. Ну, і тим не менше, я спробую теж зупинитись на основних концептах, які на сьогодні Мінінфраструктури ставить першочергово щодо їх реалізації. Що в рамках національної транспортної стратегії Мінінфраструктури бачить розв'язання напрямку актуальних проблем, тобто і зниження екологічного негативного рівню на навколишнє середовище, тобто врегулювання браку і стимулювання застосування альтернативних джерел, велике антропогенне навантаження, тобто виключення, та інших важливих негативних факторів транспорту на навколишнє середовище. Хотілося б доповнити, що в рамках реалізації та напрямку Європейського зеленого курсу Мінінфраструктури доклало активної участі щодо пропозицій амбітних кроків. Що ми бачимо і куди ми прямуємо? Плануємо впровадити маркування дорожніх транспортних засобів за рівнем екологічної небезпеки та за рівнем енергоефективності задля оптимізації екологічних характеристик продуктів та транспорту. Реалізація програми Корсіка для авіатранспорту, транспортна декарбонізація міст та розвиток розумної міської мобільності шляхом переходу на екологічно чисті види транспорту, впровадження також інтелектуальних транспортних систем та розвиток систем кібербезпеки і цифрової інфраструктури. Окрім таких стратегічних напрямків, звичайно ж, Мінінфраструктури працює і над законодавчим підґрунтям, як було вже зазначено про закон, який був прийнятий 3 грудня 2020 року про внутрішній водний транспорт, як стимулювання розвитку зеленого транспорту та часткової переорієнтації вантажопотоку на внутрішні водні шляхи. Також Даніелем було озвучено про мультимодальні напрямки розвитку. Підтверджуємо, що наразі так у Верховній Раді зареєстрований законопроект про мультимодальні перевезення, теж реалізація якого дасть змогу зменшити обсяги використання саме автомобільного транспорту і переорієнтація на більш екологічний вид транспорту, вантажоперевезень. Окрім законодавчих розробок та ініціатив, наразі я хотіла би відмітити ще такий реалізацію проєкту, надзвичайно важливий на сьогодні міський громадський транспорт України в рамках фінансової угоди між Україною та Європейським інвестиційним банком. Що передбачає реалізація цього проєкту? Передбачає оновлення парку автобусів, трамваїв, тролейбусів, вагонів метрополітену, закупівлі електробусів. Я перепрошую, вибачте, будь ласка. Так, цей проєкт розповсюджував або залучено було близько 11 міст України. Це і Київ, Харків, Луцьк, Одеса, Львів, Запоріжжя, Суми, Івано-Франківськ, Миколаїв, Тернопіль і Чернігів. У зв'язку з тим, що цей проєкт був настільки популярним, до Мінінфраструктури надійшло значна кількість заявок та пропозицій, щоб реалізувати на інших містах України, в інших містах України теж таку ініціативу. Тому наразі Мінінфраструктури здійснює ряд заходів щодо переговорів та залучення додаткових кредитних коштів в обсязі 200 мільйонів євро для реалізації другого етапу «Міський громадський транспорт України-2», який теж передбачає оновлення екологічного транспорту щонайменше у 18 містах України. Якщо коротко про проблеми, які Мінінфраструктури на сьогодні бачить для себе у кожному напрямку галузі, то, в принципі, в автомобільному напрямку, звичайно, що нас турбує домінантна позиція автомобільного транспорту серед забруднювачів. Також збільшення, інтенсивний розвиток та збільшення кількості автомобілів свідчить про показники зростання зареєстрованих транспортних засобів. До прикладу, у 2018 році зареєстровано 400 тисяч транспортних засобів, у 2019 більше 650 тисяч, а у 2020 році близько 600 тисяч транспортних засобів. Тобто збільшення, тенденція до зростання теж є проблемою щодо врегулювання негативного впливу на навколишнє середовище. В залізничному напрямку залізничний транспорт теж є, хоч і більш він екологічний, тим не менше є проблеми, які ми бачимо щодо впливу негативного на навколишнє середовище. Це використання поверхневих і підземних вод. Це акустичний вплив від акустичний шум від рухомого складу, електромагнітне випромінювання. До прикладу, в авіаційному транспорті основні проблеми ми бачимо – це викиди шкідливих речовин з авіадвигунів, шумове забруднення, електромагнітне випромінювання. Щодо морського транспорту, теж проблемою є скидання неочищеної баластної води в прибережних водах, значне навантаження на стан атмосферного повітря через викиди забруднюючих речовин від роботи суднових енергетичних установок. Тому ряд проблем ми бачимо і над цим, так скажемо, працюємо. Тому блоки і інфраструктурні проекти в частині обговорень і залучення експертів для нас є важливим, тому що і досвід європейський, і експертна думка теж важлива для реалізації, якісної реалізації ідеї зменшення негативного впливу на навколишнє середовище, а також важливим є пропозиції та рекомендації щодо адаптації транспортної інфраструктури від впливу змін клімату. На сьогодні ми бачимо такі основні кроки та основні заходи щодо потреби оцінки вразливості транспортної сфери, а також розуміння, як реагувати і опірність транспортної сфери щодо адаптації в умовах непередбачуваності. Якщо коротко, то в мене все. І дуже надіюсь сьогодні активно поспілкуватись і отримати додаткові відгуки, додаткові рекомендації для покращення нашої роботи. Всім гарного дня, дякую.
Дякуємо вам, пані Наталія, але ми вас ще трошки не відпускаємо, бо є запитання.
Так, я на зв'язку, так.
Є запитання в чаті від Оксани Кисіль, Угода мерів. Оксана, ви хочете самі зачитати чи мені його передати?
Я можу прокоментувати. Доброго дня, пані Наталя, доброго дня всі учасники. Дивіться, зараз є оголошення про закупівлю автобусів в таких великих міст, як Луцьк, Миколаїв, Львів. І скрізь, і це кредитні кошти від Європейського банку реконструкції і розвитку, і там досить 70-80 автобусів міста закуповуються, великі міста. І скрізь 100% вимога в тендеру до автобусів стоїть дизельне пальне. Тобто міста будуть віддавати ці кошти наступні 10 років. І вони зараз в 2020-2021 році роблять оголошення тендера на дизельне пальне. Це в рамках програми муніципального транспорту, те, що підтримує ваше міністерство в співпраці з Європейським інвестиційним банком і ЄВРД. Тобто, яка тут логіка? Чому пішли міста по закупівлі такого потужного автотранспорту і на дизельному пальному? Тобто це суперечить і транспортній стратегії, і збільшить викиди на рівні міст. Тобто тут якийсь іде дисбаланс.
Дякую, Оксана, за запитання. Я би з задоволенням вам могла прокоментувати, проте, на жаль, деталі умов фінансової угоди я не володію такими деталями. Я цю проблематику донесу керівництву, звичайно ж, і я надіюсь, що це питання може бути врегульовано. На жаль, я не можу вам прокоментувати.
Я вам скину в чат посилання на тендерну документацію. Тобто це суперечить тому, що ми прийняли зовсім транспортну стратегію, виводимо з міст транспорт, який є шкідливий. А зараз 21 рік.
Так, я абсолютно з вами погоджуюсь, що тут є якась нестиковка планів та стратегічних кроків. Так, якщо ви скинете мені, я буду вам дуже вдячна. Ми опрацюємо це питання.
Пані Оксана, і можливо у вас є якісь пропозиції щодо цього, вже наробки, то ви також можете ними поділитися, як ви б бачили розвиток цієї стратегії, можливо так, обмін досвідом. Якщо це електротранспорт, то, я так розумію, там має бути мережа. Це вже питання до дискусії, ми до цього перейдемо в подальшому. Дякую вам дуже. Наступний наш доповідач, ви вже сьогодні бачили Єфрат. Вона вже з'являлася, як то кажуть, як сонце в нашому чаті і в нашому відеоряду. Але тепер у Єфрат буде доповідь, і це основні аспекти адаптації до клімату та підсекторів, пов'язаних з інфраструктурою. Зараз ми запрошуємо Єфрат. Єфрат, We are asking you to...
Thank you. If you could make me a co-host, then I'll be able to do the presentation, start the presentation. Yeah. Did you hear me?
You can try now, Frod.
Okay, great. Hold on. So, hello again, everybody. I want to speak about some aspects of infrastructure adaptation in general, not just transportation, because we will have quite a few speakers about transportation. And I try to focus on those aspects that are shared across all the public works sectors, including transportation. I'm not going to speak a lot about climate risk and vulnerability analysis, though I will mention them, of course, because they're an important tool in learning how to adapt. We had separate and multiple discussions about those, so I don't want to bore those people who have participated in previous more focused discussions. Okay, I'll very quickly start with a few shared slides on the understanding of climate change. I don't know how many of you have participated in the previous discussion, so I apologize if there's a repetition. So as you all know, we're living in a dramatically warming world. We have quite a few sets of climate impacts that, from a technical point, we're all comfortable and aware of the level and frequency and intensity of the impacts that are projected. There are quite a few climate extremes that are still being figured out or more refined. A better understanding is being developed. And of course, climate change is a tremendous risk multiplier. From a social, natural resources, as well as funding aspect. The most important part to remember is that we cannot predict the future based on past events. The change is quite dramatic. This is this slide is probably, these next two slides are probably the most important ones for engineers, is this understanding that we move from a stable historic trend to a non-stationary trend that is dramatically changed from what the past was. The reason this is important is because many engineering professions and many engineers rely on data parameters tables, right, that set up the standards and assessments, and they are relying on past information. The engineering profession in general develops infrastructure based on past experience, which sets the parameters. And we're now moving into a very different world, which is a huge challenge. And lastly, we kind of want to avoid the situation where we never have a green light to move forward and adapt and have a better future. So infrastructure and climate change. The range of services provided by infrastructure in general is tremendous. Shelter, safety and security, aesthetics, heat, light and power, mobility, health and recreation, wealth creation, homes, buildings in general, transportation networks, energy networks, wastewater and stormwater networks, industrial structures, communications, landfills and waste related structures, and of course, culture and recreation. That's just to name a few. We need to address risks to infrastructure or climate-related risk because we need to minimize service disruptions. That's one of the key aspects of services. We need to obviously protect people as well as property. We need to optimize services to a changing climate. We need to better manage the life cycle of infrastructure assets that we build. We need to manage operations. We hope to avoid surprises in our operations. Reducing costs is always a criteria for any agency that I'm aware of. And lastly, understanding the risks is a critical part of understanding adaptation planning. I want to give you an example of some of the kinds of infrastructure risks we're talking about, starting on the top left, where you have sewage overflows, road collapses, that's on the bottom left, physical structure collapses, as well as another road collapse. And I want to, since Ukraine is considered a relatively cold country, I don't know how many of you are familiar with the concept of railway lines that get deformed from heat. This is something that the UK has experienced, Canada has experienced, the northern parts of the US have experienced. Florida, for example, doesn't experience this because the standards in Florida are already working towards very high heat levels. But in the northern US and Canada, where they have a lot more snow and we have a lot more in Europe, where you have very snowy regions, you're starting to see deformation of railway lines, depending on when they were constructed and some of the standards. And the other thing that you start seeing quite a lot, which is underappreciated, is collapsing of the substrate for railway design. This specific picture is from Canada, and it's caused by the permafrost. The melting of the permafrost was affecting the structures, the foundations for structures, as well as roads and railways. But obviously permafrost itself is not an issue in Ukraine, but I do think the public works and the transportation ministries need to start looking at the foundations of the infrastructure and how that is designed. That is also something that is really, really critical. You see that also obviously in the center with the road, the pictures of the road collapse. We're looking at bridges that are collapsing. We're looking at dams, drainage systems, all of which are changing due to a changing climate. I like this series of pictures because this photographer was very lucky to actually be in position to literally see the whole session of 2-hour process that it took for this road section to collapse, starting from the top left to the bottom right. And you can literally see how the road started collapsing due to a rain event, a very strong rain event in 2005. This is a major highway, and you can see how this happened. It's very rare that we manage to see the whole set of pictures for an event like this. We're dealing obviously with increasing occurrence of extreme infrastructure. It's causing damages and it's causing a lot of damage, a lot more than is being appreciated by a lot of the public works ministries and service providers. But it's providing an even higher cost to repair and replace. The reason the repair and replace is much higher is because the engineers have not fully understood or have not fully incorporated the necessary changes that are needed to make a difference. Obviously, climate change threatens the ability to provide safe and effective infrastructure. If your facility, whether it's stormwater or drainage or roads, or structures, is not designed to accommodate a changing environment, then the facility itself is not as safe as it should be. Climate engineering, engineered vulnerability assessments, which we'll talk a bit in a bit more detail, but not much, as I mentioned, is a really critical component of the design phase. It's also a very critical component of assessing risk and understanding some of the issues. For example, in Florida, South Florida, which experiences a lot of flooding now, municipalities cannot insure their service vehicles, whether it's waste trucks or ambulances or police cars, right? Because there's so many occurrences of flooding that the insurance companies are claiming the cities have not prepared enough and have not rebuilt enough, they cannot ensure that a lot of their smaller assets, the vehicles, which means that in reality, the cost to replace them is actually much higher than projected in budgets and in municipal operating budgets and maintenance and operations. Okay, so one of the reasons that climate is such a critical aspect for infrastructure in general is that it changes the load on the network, on the individual assets. And there's such a wide variety of challenges that the climate itself poses to the parameters that we design with, that it makes it really requires a strategic and consistent approach to changing things. So, for example, if this is for wind. What we see in a lot of climate events and climate impacts is that once you reach a certain threshold, the impacts increase dramatically. So, for example, this is for wind, from a survey of insurance costs for wind payments across the world, and you see that once you hit the 50 knot threshold, all of a sudden damages increase by 650%. So a 25% increase in wind strength is actually causing 650% increase in damages. So those thresholds are different for wind, they're different for water, they're different for heat. And we're seeing that what we would consider from an engineering perspective, a small jump from 50 knots to 60 knots is not that big of a jump really. But in terms of the damages, because it exceeds the capacities and loads of the design infrastructure of the engineered design, all of a sudden we're seeing tremendous jumps in damages. The reason for this is we design for load and we design for capacity, right? So capacity is what we're planning for, and load is what we're experiencing in reality. And a lot of times, for a lot of assets, we tend to load them a bit more than the capacity, or just beyond their capacity, because of the lack of synchronicity between design capacity and changes to loading. For example, if a population of a city grows very fast, all of a sudden the infrastructure is not going to keep up. So there are going to be a couple of years where roads are going to be extremely busy, or the sewer system is going to be a bit overloaded. But what that does is that by increasing this capacity, by having this gap between the capacity and the design capacity and the actual load, we're actually causing failure of the assets, right? Not the system, but the individual assets. So small changes and understanding these thresholds are really, really important. On the other hand, I should say, and I want to show an example, small changes can also make a very big difference in how assets respond. So I'll give you an example also from Florida. So I don't know how many of you are familiar with hurricanes, but Florida experiences a lot of hurricanes. Hurricanes have 20 or 30-year cycles where you have 20 years or 25 years of very low exposure, and then 20 or 30 years of very high exposures, or at least that's been the historic trend. So Hurricane Andrew in 1992 hit Florida and literally was the first storm to hit Florida after a huge gap, a 30-year gap in hurricanes. During that period, the population of Florida grew from 4 or 5 million to something like 12 or 15 million. So it created a huge amount of damage, which I'm not going to go into. I can talk about that for a good couple of hours, so we're not going to go into that. But at that time, in 1992, it was considered the most expensive disaster that the US had experienced. one of the things Andrew did, because it came after 30 years of not experiencing hurricanes, is it actually generated quite a lot of changes to how construction and building is approached in Florida. So it improved land use planning, it improved restriction development in certain areas, increased the requirements for open space. The Florida code is now updated, the building code, what they used to call NIPS SNIP in Soviet time. I don't know what Ukraine is using now, is now updated every 5 years to adjust for climate impacts and to adjust for new technology. So think about that. Every 5 years, we go through a review of the building and standards for every single public asset and structure. However, building costs in Florida are at least 15% higher than any other state, but there are improved construction techniques. There's quite a lot of non-structural mitigation aspects, which I'm not going to go into. The reason I want to show you this list, because these are all, even though they were implemented for disaster reasons, they could all be considered adaptation of the various sectors to a natural disaster and to changing climate. One of the things they did is change, as I said, the design code, the engineering requirements. And we have here an experience from a hurricane, damage from a hurricane after 2004. 2004, there were 4 very strong hurricanes that hit within a 3-week period. So it was quite a lot of damage to structures. And you can see on the foreground, a structure from that was built before 1992. And a structure that was built in 2002, that the difference in the damage is quite significant. And when you think about it, what was actually the difference in this damage is they actually changed 2 things. And this was the roofing. So they changed the toe nailing, which is a type of connection that you do for the nails, and the metal anchors, which connect the trusses to the beams. And if you look at the damage per distance from the coast, of how much money per mile happened for the insurance company. So on the left-hand side, you see the damage for structures built before 1992 based on the 1980 code, which gives you an idea of how long it had been since the code had been revised. And on the two lines that just showed up show you the damage after the 1992 changes started coming into effect, with structures built after 1992 when the new code started to come in. And all they changed were 2 types of nails, right? This is 2 types of nails on a roof. And this created this much reduction in damage to structures. So this so while yes, there's tremendous damage that can be caused when we cross the climate thresholds and we get these huge jumps in impacts, we can also do quite a lot of changes by better understanding of the risks facing the structures and the assets and the systems, and how to reduce them. Because we have a better understanding of the risks and vulnerabilities, we can be very targeted in our approach. And in the end, changing the types of nails that you use for a roof is not a big cost for a builder, right? But it's a tremendous savings and reduction in vulnerability for the structure, as well as obviously the people who use that structure. So infrastructure vulnerability analysis, just like every other type of vulnerability analysis, relies on understanding exposure, sensitivity, and adaptive capacity. The additional aspect that really needs to be considered are the technical parameters. Because any asset has a set of technical parameters that define its capacities. So when you're dealing with asset vulnerability analysis, whether it's a structure, a road, a wastewater facility, or anything that we would consider public works or structures, you also need to consider the technical parameters of that individual asset. And where does this come in? Design life varies. So houses and buildings, you can build them from anywhere to 50 to 100 years, but mostly they're looked at for serious renovations within 20 years. storm and sanitary sewers. They usually built for, the system is designed for, it depends from country to country, but the basic components usually have a design life for 25 to 50 years. But the system capacity or service area is kind of considered for 50 to 100 years. Dams and water supplies typically have a 60 to 100 year period for the serious structures, the big structures. Obviously, the smaller service piping has a much shorter design life. Roads and bridges have quite a lot of variability. Bridges are designed between 50 and 100 years, but road surfaces such as asphalt, anywhere between 5 and 20, depending on the surface. Asphalt is every 5 to 10, concrete is 10 to 20, it has a lot of differences. So this makes a difference to the structures. And we can go through, houses from bricks and concrete as opposed to any other material, all those kinds of things. All of this has adds another layer to vulnerability analysis and understanding the technical capacities and how they change and how they impact not only safety and economics, but also the socially reliant aspects of these networks. Which brings us, am I speaking too quickly, by the way?
Oh, it's okay. We hear you.
You're keeping up with me. Okay, good. So basically, we need to start thinking more about system resilience and asset resilience, which is the ability to withstand a much wider variety of climate impacts. Basically, from a technical point of view, this means that we need to have a wider set of parameters, design parameters that any asset is working for. Why is this important? So if we think of a matrix of risk and infrastructure capacity and time in a context of some climate scenarios, some good, some worse, and we start with where the blue line reflects where we stand with our current infrastructure. As soon as we have a risk event, there's an increased awareness of potential risks in an asset. But it takes time to adjust the asset, not only in terms of planning, but also in terms of construction, because all public works assets have a very long planning and design life comparatively to some of the smaller adaptations. So what we see is these big jumps in increased capacity before we stabilize at a new level of capacity. And we repeat these cycles for all infrastructure assets. So basically that means that we need to understand that transition from understanding the risk to incorporating that into the planning period of all infrastructure assets. That's a very intensive awareness and technical understanding that has to jump up very quickly in order to quickly be included in future plans. And then we also need to understand this transition towards the end of the life of an asset, of how quickly the new parameters need to be integrated and are verified and validated so that we don't face collapse of structures. Some of the lessons learned around the world from climate risk assessments for infrastructure is, first of all, the short, intense bursts of changes, whether they're extreme rainfall events, extreme heat, are a lot more disruptive to assets than assessed, just because usually they exceed the parameters. I would say about 90% of infrastructure assets are vulnerable to gaps in the power system because of energy outages. So that is a huge issue, especially as we rely more on optimized networks to balance the network, to optimize use and to monitor what is going on. Combinations of events tend to have more severe impacts than individual events. And most importantly, the engineering curves that we use for design are severely updated around the world. This is probably the biggest the biggest gap that exists around the world in terms of adapting quickly. As I said in the beginning, engineers rely on these curves to design, and very few engineers are willing to develop a new set of curves without peer review and without looking at what is happening around the world. There's a lot of differences between different countries. For example, the US has two sets, one for the southern US and one for the northern US because of the differences in temperatures, right? But Europe has one set. So even though on asphalt, for example, Germany goes up to 50 degrees, the European code actually doesn't go up to 50 degrees. So if you're using the European code as opposed to the German code, how do you balance that, and how risk averse are you? And we should be pushing our engineers in their original design thinking to go up to higher extremes, because in the end that is cheaper and more cost effective than having to fix things further down the road. Multidisciplinary teams, I don't think we need to talk about, but that's really critical. Engineers tend to be very focused have very siloed understanding, and having wider teams working in the design phase saves a lot of time. Obviously, climate projections, you need to have good data. You need to make sure your baseline data is accurate, and monitoring and maintaining. You'd be surprised at how many systems are not really good at monitoring and maintaining not only weather events, but also the impacts on infrastructure. So asset management becomes really critical. The key aspects here, as I said, of climate risk vulnerability analysis, and identifying the nature, optimizing design, quick identification of vulnerabilities, a very structured approach to how you do the analysis, adjustments to the design, planning, and operations, application of new designs, and adjustment of codes and standards. I'm going to give you a very quick pop quiz. If we have a standard composite bridge, which has a steel and concrete combination in the bridge, how many points of weaknesses do you have for climate impacts? Just very quickly, I would appreciate if people could just throw in some of their thoughts.
Панове, ви можете озвучувати свої думки будь-якою мовою. Скільки вразливих місць є в даному випадку в будівлі мосту?
Мова йде не про вразливі місця, а вразливі, скажімо так, точки. Це перше, це підняття рівня річок у разі підняття, це перше. Друге, це, скажімо так, розширення металу при підвищенні температури і її стійкості. І це я як не інженер, а як кліматолог можу сказати. Дві точки.
Це ще й корозія, мабуть. Галина тут пише. Ifran, can you hear the translation?
Okay. You're absolutely right on all 3 points. Let me add a couple of more, some of the additional points that need to be required. So concrete steel interfaces, they expand and contract with temperature at different rates. The more extreme our temperature gets, the more the differential between them becomes, and it needs to be adjusted for. These differentials also start affecting the use of rebar in concrete, the use of the steel in the concrete, right? The depth of the steel within the concrete needs to start changing, or needs to be considered to verify that it will not warp the concrete. The pylons and foundations, if you're looking at drought extremes, then we need to be looking at much deeper foundations so that you go to a much, or obviously pilings or other foundation methods. If you're looking at flooding, you not only need to raise the bridge itself, but you also have faster water flows. A lot of times you have, so the pylons need to be stronger. You need to have more protection from debris. You have more erosion of the banks. So your whole bank protection measures and your abutment measures are much bigger. The drainage system on the bridge needs to change if you're looking at more precipitation. If you're looking at more precipitation and if you're in a curve, the water sheeting might affect the safety of the bridge. So you might look at the surface treatment, not just asphalt or scraping or some other mechanisms that you can put in. And most importantly, the age of the bridge, right? Concrete ages faster in really hot temperatures, depending on which country you're in. There's some preliminary information out of Australia that's talking about faster aging of concrete that's quite significant. And also steel integrity, as we saw with the warping of the rail lines at high temperatures, the steel can warp also. This is just some of these things. I'm not a bridge engineer. So think about this. I don't know how many bridges you have in Ukraine that look like this or any other type of bridge, but how many of them were constructed in the last 5 years compared to how many were constructed 50 or 60 years ago? In most countries in the world, a lot of the bridges are really old. Replacing a bridge and designing it, you're now designing it for not for the certainty that we know of climate impacts within the next 20 years, but we're looking at bridges last a long time. They can last up to 100 years, at least 50 years. That's the minimum for a viable bridge, right? We don't have the level of certainties that engineers want for climate. They get really worried when they start hearing the uncertainty levels for the century mark, the 2100 temperatures or rainfall. But they need to start designing new bridges for that. And I'll ask you something more. How many of your bridges are toward the end of your life? And you, as a transportation or public works institution, have started looking at how many of them are coming up for replacement in the next 10 years or 20 years. And you need to start looking at their design parameters differently, not only for traffic and other aspects, which obviously have to be looked at, but literally at the stability of the structure, at your ability to provide a replacement bridge in the same location. So some countries have it easier. They're flatter, they're not as terrain. I had this discussion in Georgia when I was working there, and the number of bridges that they have there and the number of assets that they have at risk is tremendous. And I was told very clearly by the Georgia guys, they were very proud that they're using, a lot of those bridges were constructed in Soviet times, and they were built to the highest extreme of SNP. And I said, that's great, except that for the last 5 years, you have already experienced temperatures and rainfall that is exceeding the parameters, the design parameters, the very extreme parameters of SNP that was designed in 1960 or 1970. That doesn't say that SNP doesn't have extreme weather section. It does, except it was never used in bridge design. So all those old structures need to be looked at. And we had this very long discussion about this. Now, Ukraine obviously doesn't have the terrain that Georgia has, but that doesn't mean that you don't have bridges, you don't have. So all I'm saying is basically, we have a lot more weak points in a lot of infrastructures than we realize, number one. Number two, the solutions to a lot of these issues are known. If you sit down any engineer and say we are going to have twice as much rain on the bridge that needs to be drained off, that's not a difficult solution. Technically, it's a very easy solution. The difficult part is getting the engineer to accept that transition to a higher range of water flow or a higher range of temperatures. The technical capacity, the technical design options are very easy. They're there. They're known for a very long time. The difficult part is getting the engineers to start using them in structure design and to start thinking of a more systemic approach to these things. I want to show you, if you'll allow me, some of the interdependencies that we're talking about and why this is so important. So if you recall, from a couple of sessions ago, we talked about vulnerability analysis that I'd done in Minnesota. So I'm not going to bore you with that. So after we did the vulnerability assessment, we actually did, we mapped this out for the whole city, not just the neighborhoods. And we looked at that in the context of a series of assets. This is for flooding. We don't need to go into the details right now, but just to show you, if we're looking at highways and transport, by having this online, all the agencies can see the data, right? They have better access than we have here in the story map. But you can see here that we see the exact segments of the highway that are at risk, so that the transportation, the highway division can actually look at which areas they have that flood more frequently and are at higher risk, and can start adjusting their budgets and their maintenance schedules to adjust for that. But also they can start adjusting for planning for replacements to do forward. We did this also for transit, the commuter transit stations and the commuter transit spots, the bus transit areas, which ones are at risk and which ones aren't, the facilities, including the maintenance facilities, because if we don't have access to the depots to fix areas, we won't be able to. Wastewater treatment plants, which ones, and the access points. Access is a pet peeve of mine. I think insufficient attention is paid to access to facilities, and they tend to get isolated. We see this a lot with hospitals especially. And I mentioned this briefly in our session on healthcare. Maintaining access to the facility is probably one of the highest priorities that you have, because if you can't maintain access to the facility, you're never going to be able to fix the problems once there's an event. Hospitals tend to not be considered as priority access areas in the transportation design systems and for flooding events and or access in general, even in heat events. And that needs to be looked at a lot more seriously to how do you maintain a high level of access to critical facilities? Maintenance holes, we did an assessment of just about every single maintenance hole and which ones are flooding and which ones are not, so that we can adjust the maintenance schedules for the city here of Minneapolis. Okay, this goes into some of the other mitigation measures, but I wanted to show you this because you can see how one good vulnerability assessment that is done correctly can help you address a lot of the interdependencies that exist between assets, even some that don't seem to be very obvious or very critical at the immediate point. And that's sort of me getting off my high horse of vulnerability assessments right now. But the point I'm really trying to make is the need to think both nationally for the system context, but also locally, have a much better understanding of the context that the system operates in for all systems. So I want to give you another example. If you were asked today, most people who don't know the US and were asked which one would be the most important port in the country for delivery of goods, for incoming goods, most people would say New York. Some people would say Los Angeles. Very few people would say Texas. And virtually no one would say Louisiana or New Orleans, for example. Well, this is not quite New Orleans. This is between New Orleans and Biloxi. This is the reason that Katrina was so expensive. Because once Katrina hit, the damage to New Orleans itself comparatively was not much. That's not to detract from the damage there, but the social damage was much bigger in New Orleans than the structural damage, comparatively speaking. The damage to the economic system in the US, because of the dependency on New Orleans as an incoming port for transportation of goods and fuel, was the reason that the economy suffered so badly after Katrina. The fact that the US Corps of Engineers, who's responsible for the levees and the drainage system and the water system, did not understand the high level of dependence of the national economy on New Orleans as a port prior to Katrina, means that they didn't prioritize work that needed to be done in New Orleans compared to other cities that were prioritized for other reasons. And that is something that all the prioritization processes needs to start taking into account, not only your immediate local impacts, but also your wider national, regional, depending on where you're located, impacts. If we look at combined truck flows, meaning not just fuel, but also trucks, you see how important Louisiana was prior to 2005 to the transportation and delivery network in the US. It was also the primary center for delivery by waterways. So once the rivers were flooded because of the hurricane, you couldn't use the waterway system to transport goods either, not just the roads, but also the waterways. Anyway, I just wanted to bring this up to show how critical it is to understand where your real vulnerability is. And where your weaknesses in the points are. Adaptation is about understanding where your weak points are and fixing them so that the system can retain its service capacity. I want to go into a couple of case studies now. This is I mentioned earlier, the assessment we did. How many people are on the webinar that have already seen this? Can you give me a quick number so I don't repeat it if everybody's seen this?
I think that we have new participants, and anyhow, we would like to listen this once more. So
okay. Okay. So basically, we started with an assessment of vulnerability of the stormwater. The Minnesota had experienced quite a few flooding events that caused a lot of damage. Minnesota is in an area that is facing a significant increase in amount of water and precipitation that it's going to be looking at. And the watershed itself, this area of Minnesota is called the 10,000 lakes. It has a lot of small lakes and small ponds. So it's obviously very flat. So if we look on our right-hand side, you can see that the design standard is here. This is the design standard in 2013, what was happening. But all these events that were happening, as you can see on the right-hand side of the screen, were actually exceeding the design standard. So we already had a situation where the code was not meeting the existing demands, let alone what was happening in terms of future predictions. So we basically built a vulnerability model based on EPA SWIM as well as climate projections. And we identified what the new design storm capacities need to be. As you can see, at the best level, we had to increase the system capacity by 10%. The most pessimistic level, we had to increase it by 157%. And then we ran the models on the drainage system. And you can see there are quite significant parts where we have a lot of surcharge. Not only do the drainage not sufficient, but it overfloods and goes above the sidewalk curbs. And what you see is that there's a significant jump, even though if you look on the left-hand side here, here, we're not really jumping by a lot in terms of the amount of precipitation, only 3 additional inches, which is not a huge amount. The cost here jumps quite significantly. We went from almost 7 million to almost 40 million. So that's a huge jump in cost that literally panicked the municipal leaders here, because they were like, we're not going to be able to afford it. We're going to have to raise taxes. We're not going to get the money to do this. how do we fix this, right? Well, one of the things the team pointed out to them was that they were looking at the wrong number. The number is not the cost or the length of pipe that needs to be replaced. The number is, sorry, oops. The number is this one. How many millions of gallons of water are you going to have to flood and address the flooding? And if you look at it like this, and you look at what the real damage is, then your adaptation options that you're looking to integrate, whether it's upsizing of pipes or underground storage or dry detention basins or whatever other system you're looking at, is comparable to the amount of flood that you get. Because if we look at the cost of damage per flood that we're getting at $1 million per million gallons, then you see that this is the number that you need to be worried about. And if we're looking at this number in the context even of this amount of flooding, then we're looking at $1 billion of flooding of cost. So $38 or $39 million compared to $1 billion is actually not that big of an investment in terms of the benefits you get by providing safety to the structures, to the system, and to the people who are experiencing this flood. If you're only looking at the difference between option A and option B, that's a big difference. But if you're looking at this in the context of the flood, which is really what we need to be looking at, the damage, then we're talking about a whole different set of data and cost combinations, after which you understand why the city was very eager to do a full assessment, not only of problem areas for flooding, but a better understanding of how it's impacting all of their systems, which was that other program I showed you. Okay, so the key points really are, we need new and updated codes and standards to reflect climate projections. That is absolutely the key. Engineers are going to be very leery of moving forward without a better understanding of what needs to change. We need to have a better forensic analysis of engineering design. We need to be much more upcoming and forthright about why design failures occur for structures. And we need to really start looking at all the assumptions that go into design of certain infrastructures. Asset management is key. I cannot stress this enough. Maintenance schedules, maintenance budgets, asset management is incredibly important. I haven't talked about it now. We'll talk about it in the climate finance, but just to give you an understanding, the World Bank projects that every year between now and 2050, or they started in 2010, maintenance costs are going to go up by 3% per year if we don't address the design of infrastructure. And this is just for road transportation. Now, I don't know what your maintenance budgets look like in Ukraine, but I know that every single country I've ever worked in, nobody has done 100% of the maintenance they're supposed to do in a single year. So the less maintenance you do, the more your gap grows. That means that every 3% increase, you're never catching up. You'll never be able to address the changing climate because you've never caught up with historic maintenance. And if your systems are not maintained properly, they're never going to perform at 100% capacity. So every year you do not do your maintenance budgets properly, and you skip maintenance because of whatever. It means that you're reducing that much capacity from your system already, and then you add on top of that climate impacts. That means you're reducing your capacity by that additional much, and this is why the systems start collapsing, right? And we need to start addressing that much more concretely in budgets. And lastly, understanding the interdependencies between the systems and the importance of making sure that road transport to healthcare facilities stays at 100%, that wastewater systems, that every single system is optimized, and we all understand that a power outage will not only cause a power outage, but it could also cause a problem with a sewage plant and with streetlights and God knows what else, right? Having every sector understand the interdependencies much better, will help adjust the system on how we move forward. That's really my presentation. I'm happy to answer questions if you have any at this point. Or Olga, or are we moving into a break now, or what?
Yeah, Efrat, actually, our chat is very active today. And,
okay.
Yeah, and there is a great discussion, and because you touched a very vulnerable point for us when you showed this picture with the bridge. I remind that I saw the last year the same bridge, or a couple of bridge like that with steel and concrete in Ukraine. It was in Carpathian Mountains, and we had the same problem for these bridges. Although they looked very strong, but they were demolished by high water. And actually, the river is very shallow there. In normal times, usually the river is very shallow and small, and you just can walk this river. But the bridge was demolished absolutely, and there was, I counted just 3 bridges for one village, for one small village. So we have a great discussion in our chat. You can open that, and people are writing a lot of questions and their observations also about that.
Yeah, so first of all, bridges are a particularly weak point, and that design is probably one of the most common design for bridges in the world. There are a lot of bridges that are facing this, but bridges, because there's such, not just bridges, but all systems that are really long-term systems, we tend not to think about their need to replacement so much because, you know, they're there for 60, 70, 100 years. We don't understand how the climate is reducing their design age. So, and how all the changes in climate are impacting them. Or we do understand it technically, but we don't understand it emotionally, you know, for other purposes. So I'm seeing, yeah, Anatoly made the comment that the freeze also affects concrete. Absolutely, not just concrete, but all systems. Yeah, there are technical issues that come with that. I'm not familiar enough with the specifics of the climate change projections for Ukraine to give you more specific examples for Ukraine. But I agree, there's still quite a few parameters that need to be refined. There are better people than me to comment on the issue of 0-degree temperatures, other than to say that in general around the world, we're seeing less colder days and more hotter days at higher extremes. That doesn't mean that we don't have freezing temperatures that are unexpected. 4 years ago, for example, the carburetor in my car cracked because Florida experienced a rare cold. Florida does not get a lot of cold weather. And we went below 0 for 3 days in a row, and my carburetor cracked because I didn't put antifreeze in. It was not expected, all these kinds of things, right? Obviously, Ukraine has a whole different temperature. I doubt that anybody in Ukraine faces issues like a cracked carburetor in an old car, but these things happen, right? The facilities change. Freeze-thaw behavior is absolutely a huge asset, a huge critical parameter for design, not only of concrete and steel, but a whole set of other. It also shifts the ground, especially in the northern areas. The ground shifts a lot faster than it does the expected. The use of salt is very corrosive. It changes the interaction with the metal components in all assets, the strengthening. It also corrodes concrete a lot more. So there are huge amounts of issues that need to be faced. Sorry, I'm looking at Mikola's question. Right, so, when I started banging out about the need to change codes about 15 years ago, I was one of the few who was talking about the need to change engineering codes, that it was more critical than some of the sexier renovations that were being looked at. I think today, definitely in the last 5 or 6 years, it's pretty much accepted around the construction industries in all sorts, all public works related industries, whether it's transportation or structures or facilities, that we need to look at different design and building codes. Europe, if I remember correctly, has just finished revising its building codes. I want to say less than 5 years ago. This is the European code. The problem with the European code, however, is because it's an average code, right? Because it has to accommodate countries in the south as well as countries in the north. So you're looking at individual averages, whereas individual countries might have more specific changes. Germany has become very good about revising its building code. Britain has started revising its building code. Switzerland is revising its building code. There are quite a few countries in, I know Armenia and Georgia have not revised their building codes yet, but they're looking at it. It's on their activity list for their national adaptation plans. Moldova has definitely started to revise its building codes. At least they've revised it for the transportation sector. They've started looking at it. And I think Serbia has also started in your region to start looking at revisions. I don't know how much they've done, but I know they've done. Now a lot of the post-Soviet countries, a lot of them use the SNP for a very long time. But like I said, at least in Georgia, even though SNP had a section for extreme weather, it was never used. So it's also a matter of awareness among the engineering professions and the designers to use the existing facilities. Obviously, each country has its own code in addition. I would highly, highly, highly recommend that you put in a schedule to adjust building codes. You don't have to do them all at once. Some of them are more important than others. And to put in a regular process to update building codes. I think what the US is moving towards a 5 or 10 year update, depending on the state. Canada is also in the same kind of program to look at the building codes and parameters is probably the smartest thing, because it allows you to continuously revise things without going through a very cumbersome process. Because you're continuously revising, it becomes updates of small segments that are most critical within a 5 or 10 year period, rather than rewriting the whole code. There's a lot of adaptations that we can do, and a lot of aspects that can bring in provisions. France, for example, has put in, as part of the Green New Deal for Europe, is putting in a requirement that 50% of all new structures, multi-story structures, are going to have to go to 50% use of wood, not just concrete. So yes, they're doing it for mostly for carbon mitigation reasons, because the concrete industry is incredibly carbon intensive. But all of a sudden we're talking about construction with wood, which I don't think we've been looking at seriously for more than 100 years in most countries in the world. So that's bringing in a whole new set of engineering parameters and loads that need to be looked at. It's going to have to change the systems. I want to also bring to your attention something that I don't think most people realize. We talk a lot, for example, in mitigation about the move to electric vehicles. So beyond the systems that are going to be needed for engineering, if you have an electric battery for a car that bursts on fire because it's in an accident, our current fire system that most countries in the world use can't put it out. And it's considered a hazardous fire. So we also need to start looking at training for firemen and making sure that they have the capacity to put out challenges or addressing challenges with new technology. So while I don't think it's something we need to deal with in the next 5 years, if you have to replace your entire fire engine vehicle system because none of them can address electric vehicle fires, then that's a big budget line, right? The training that firemen need to go, that would be a big budget line. So if you're seriously promoting electrical vehicles, you need to look at that. Electric vehicle fires also hotter, so they react differently with because of the some of the corrosive material in them. The combination with heat changes the concrete around for the roads. All of these are things that we need to start looking at, and we need to ensure that our parameters start addressing. There's so much discussion about the autonomous vehicles and the charging aspects of it, but there's so many more aspects to a lot of these new technologies that we're not looking at in terms of their impact on wastewater or on water supply. Or we see in California, for example, that because the wildfires are burning hotter, they're actually melting some of the underground piping. So places where we have combinations of steel, iron, and some of the plastics, they're melting and they're getting into the water supply. So the filtration systems on the water supply, it took a while for the engineers, it took about 2 years for the engineers to pick up that there's now carcinogenics from the reaction of these materials, which are not supposed to melt in most of the parameters that we use for these underground systems, right? All of a sudden they were showing up in the filtration systems, they weren't being picked up. How we deal with that? All of these are starting to show up, and we need to be a lot more flexible. We cannot rely on design parameters for 50 years ago. We have to look at every single assumption and every single aspect, and it takes time to do it properly. So I'm not going to tell you not to do it, but I would highly recommend that your adaptation activities and your adaptation plans for all of the infrastructure sectors start looking and putting into commissions or review panels to start looking at some of what Ukraine needs to do, specifically in the context of Ukraine's design standards and the changes that Ukraine is expecting. Okay. I don't understand.
There is also a question from Andrew Queen. Andrew, are you with us? You can just say.
I can indeed. It was a very small question about the Twin Cities study as to whether your flooding maps were based on current precipitation levels or projected. It was a very minor question.
Right. No, fair enough. So the original, so it actually both. We did 3 levels of flooding. We defined it as tertiary, primary, and secondary, with tertiary and secondary being tertiary being current, being the least impactful, secondary being short-term flooding, including projections at an optimistic level, and primary being most pessimistic scenario, pushing the edges not only of the system capacity, but also of, as far as we can go with the climate projections.
Okay, thank you.
Sure.
Okay, I think that we have a lot of questions for Efrat, but now we have to make a break. And let's put all the questions to the discussion, because we will have the time for discussion in the end. So please, dear friends, come back to us. We will see each other at 2:15, and now we will have a break, okay? And see you all. Thank you, Efrat.
See you all. Sure, welcome.
Я бачу, що нас вже 45 осіб. Я думаю, треба продовжувати. Я сподіваюся, що всі вже зібралися, хто хотів бути з нами. Хтось підняв руку? Чи це випадково? Якщо щось трапилось і треба додати, то кажіть. Добре. So, the next speaker. What has happened? I'm sorry. Do you hear me well? Yeah. So the next speaker is Kyriakos Ktenas. He will tell you the best examples of the national practices, how to make the transport greener. And as Kyriakos is the new speaker in our webinar, I will say a couple of words about him and about his experience. So Kyriakos has worked as a transport consultant in Atkins in London before joining the European Commission in 2005. He has worked in the Directorate General of Energy Transport and since 2008 works on infrastructure and transport investment in the Directorate General of the Regional and Urban Policy in the European Commission. So, Kyriakos, now the stage is yours, and please tell us the best practices and examples.
Thank you very much, Olga. I hope everybody can hear me fine.
Yeah, we can hear you well.
Yes, so I'm glad to hear that. I will try to break down this time in terms of 15 minutes of presentation and perhaps 15 minutes of question time, hopefully. I will not exceed my time too much. First of all, as you are aware, we have a number of initiatives at EU level concerning the support, both at technical level, as well as in terms of specific standards. For example, we have a guide to cost-benefit analysis, which was issued 6 years ago. The whole point is that we offer various tools of support in line with international best practice in order for our member states and all potential partners to realize their potential in terms of transport. From the point of view of a specific region that we are discussing, it appears to me that it is quite a transit region between Central Europe and the Caucasian region, as well as between Southern Europe and Russia and beyond, Asia, etc. We have one important element, which is the revival of the Silk of the Belt and Road Initiative, which concerns freight between Europe and China. In this particular revival, there is a tremendous potential for greenhouse gas emission cuts, since much of the freight used to go by the seas, by shipping. And gradually, this is being transferred to rail. Poland has already used this prospect by upgrading and modernizing horizontal west-east, east-west axis, which this is the line which goes via Belarus to Brest and beyond, of course. This has tremendous potential for environmental benefits, greenhouse gas emissions, and a transfer from maritime to rail of freight transport. When we talk about transport, what do we mean? First of all, we mean all activities done by the government in a country, including in its regulatory role, and which extends typically to rail, road, air transport modes. I will leave shipping out of the scope of today's presentation, although I come from Cyprus. So let's see, first of all, what is the issues at the moment. The issues at the moment is, from what I can see, an insufficient or a lack of investment in main transport needs. This also is a case in Europe, but also I suspect the case in the countries you are taking care of. Specifically, the problem concerns roads, and particularly the connectivity of many rural areas, which remains a big challenge. This challenge is not only a transport challenge, it's also a challenge in terms of social integration and in terms of minimizing the people who are excluded from main opportunities of society, such as work, leisure travel, etc. The electrification of the rail network is something which is still ongoing, particularly, for example, as an example, Ukraine has electrified about half of its total 22,000 kilometers of rail network. And the model in terms of who gets the money, because it's not only important to analyze things from a general perspective, it's also important to look at who gets what. For the rail operators, what is really important is freight. And freight, in fact, has spillover financial revenues, which are used in many cases to subsidize passenger transport. Therefore, the opportunity for surpluses to be used to upgrade the network is not in all cases evident, since many of the surpluses are directed to covering everyday needs of passenger transport. This affects route and rolling stock refurbishment. Typically, therefore, transport proceeds are not ring-fenced, meaning they are and can be used by the government to address various other policy objectives, such as health, schools, etc. This is what we're dealing with. In specific cases, we in the European Union have encouraged the upgrade of lines to 160 kilometers per hour. However, in the event of strong issues, we also have accepted 120 in many cases, such as in difficult topographies in mountainous areas or areas where going to 160 simply didn't make economic sense. Therefore, one needs to look at the transport network, first of all, as a whole, before addressing specific needs. Needs to look at the network as a whole, needs to look at all modes of transport, and any objectives and any investments and any operational decisions have to be taken in the framework of an integrated transport approach. The expressways are sometimes of international standards. Sometimes they need specific upgrades. There are also a number of issues related to what I called record keeping. If you are going to take transport decisions, you need to know where you stand today. You need to know where you stand today in order to have a vision for tomorrow. You need to be equipped with specific statistical tools. For example, in terms of car ownership, we have an explosion, as I understand, in the countries that you're taking care of. In much of the European Union, we have a saturated level at the moment, except perhaps in the Eastern member states, Central Eastern member states who joined after 2004. For example, in the period 15 years from 1990 to 2004 in Ukraine, there was 70% increase in car ownership, which started at 110 cars per 1,000 people, which is a very low number. The challenge, therefore, the strategic challenge for these countries is to maintain, to the extent possible, the high rail modal split which they have. And this will not be very easy. At the same time, there are very important challenges for cities where populations are concentrated and where emissions of nitrogen oxide, particulate matter, and nitrogen oxide and dioxide need to be properly managed. I add also sulfur dioxide and carbon monoxide, major public health issues. Therefore, it is clear that the needs of a country as a whole will not be the same as the needs of a large urban area. When I was looking typically at Ukraine, and I very much suspect strongly that this is the case in the other 5 countries that you are dealing with, what I saw in terms of transport needs for the country of Ukraine and the city of Kiev is 2 different things. The needs are not the same. And what needs to be done is that a proper analysis of the needs of the capital has to be only done in the context of the national approach. The national approach has to be permitting of a regional approach, but it cannot be sufficient. The national approach would not be sufficient for the specific needs of cities. I move on. Another issue is in terms of statistics again, the fuel quality, the vehicle technical standards. There is a need for comprehensive legislation and enforcement, for example, of catalytic converters in older as well as new vehicles. And there are a number of statistical gaps that need to be filled. Competent bodies need to collect systematically data on traffic flows so that decisions on investment will be able to be taken, will be facilitated. Another thing, for example, which happens typically in countries is, if I take again Ukraine as an example, but probably this applies everywhere, various people who are in charge. And when various people are in charge of something, often nothing happens. For example, in the case of Ukraine, we have oblasts, we have various ministries who deal with different elements of transport, and we have city authorities, for example, in Kiev. The framework for these entities to work together needs to be there. There needs to be a specific framework. There needs to be a specific way of doing business, taking decisions, prioritizing investment opportunities, addressing issues related to government, to the discharge of government regulatory responsibilities. There was recommendations, for example, from the UN Economic Commission for Europe regarding to a number of these elements that I have talked about. What I have tried to present is a picture of basic things that need to be in place before decisions are taken. This is very important. At the same time, I would like to say something. We are trying to look at how we invest money in the best possible way. Normally, we don't have enough money to address all the transport needs of a country, of a society, of a city. But what we can try to do is we can try to spend the available money in the best possible way. Typically, this means that the way that we will spend the money is not far from the optimal solution. We invest where there is demand, but we use surpluses to provide essential services to communities and people who are perhaps more isolated from essential functions of a society. It could be jobs, it could be hospitals, it could be anything related to normal life of a citizen. What we have also seen in a number of cases in the Western world is not only technical studies, but we have also seen political initiatives. Governments often realize they don't have enough money for transport investment. Therefore, they pursue other models, such as public-private partnerships, enabling the public and private sector to work together. Creating the environment of trust and teamwork is not easy, but it is often possible and it is often very useful. When I look at specific communities and how they have been transformed in a matter of a couple of decades to real transport hubs when they were simply derelict and insecure environments, often areas that even the police wouldn't dare to go there. How did this transformation happen? It often involved PPPs, but when I see all the different types of interventions that have transformed areas in a country, what I always see is a vision. I see a vision. I see a long-term vision in terms of where we want to go. What is extremely important, in my opinion, is that each country and each city, each region, take decisions based on their specific needs, using, no doubt, the experience of best practice from abroad. But in my opinion, what is the key is adjusting it to the realities on the ground. I have often seen copy-paste solutions from abroad which simply do not work. And one last element, it is very important that the politicians realize that transport is not only about large projects, it's not only about cutting the red ribbon on huge buildings and huge infrastructure. Typically, there are a number of small initiatives that produce a much larger return for the public than these large investments. And with these words, I will open the floor to questions.
Oh, thank you, Kyriakos, so much for your advice. Yeah, and dear friends, dear colleagues, do you have questions right now to Kyriakos? I don't see the chat. Oh yeah, what is? Yeah, here's the question from Galina Tripolska. What is needed in transport for Kiev and what is for Ukraine? Can you tell us your opinion, please, according to our country?
I have worked, as I said, I come from Cyprus. I have worked in London, in Brussels, but one of the things I have done in the European Commission was I worked for 5 years for Hungary between 2008 and 2013. And I can share with you my experiences and you can perhaps use your judgment to see whether any of these recommendations will apply, for example, to the city of Kiev. But I suspect that they would be quite relevant. And the same recommendations I would probably make for my home city of Nicosia, as well as a number of other places. What is very important is, first of all, to have a competent authority which is in charge of transport for the capital. It could be an executive body which is under the control of the mayor, therefore having both technical capacities as well as political accountability, but also political authority, political legality. You know, the authority of an elected mayor and the technical capacity of a body in charge of transport for the city has been proven quite useful in the case of London. London didn't always have a transport authority. It only created it a couple of decades ago, perhaps 3 decades ago, more or less. And in this particular question, I will direct you to what happened, for example, in the case of London, because I believe it is a large city, and Kiev is also a large city. And also perhaps at the national level, the populations of the two countries are not very different. There are differences, but I think the authority has to be there. The first element is to have the authority in charge of decisions. And we often have a very tragic situation in large European cities where we have a number of small mayors. We have cities, for example, which are divided into 20 different municipalities. In my home city, we have 10 municipalities, for example. And it's very difficult for them to work together. Therefore, often what happens is that at national level, they simply take all the responsibilities for signing contracts for buses and all these things, because they realize that at purely regional level, you have a Donnybrook, you have a dogfight between politicians and it goes nowhere. But I think this is a trap that it is important that we avoid by having a comprehensive authority being both in charge, but also being politically accountable. At the same time, one of the things that happens, for example, in the United States, which is not often discussed or presented in seminars, but it is a very interesting approach. What is happening in the United States is not what is happening in Washington. It is what is happening at state level, with regional decisions taken at regional levels and with even local referendums on large investment projects, with specific financial costs from local taxation being part of the poll. Therefore, it is not simply a question of asking the citizen, do you want this investment or not? It is also most important that you identify and you're honest about who pays what for something. And typically it's very important, particularly in local referendums, that you avoid giving somebody a say who is not going to pay for it. This is obviously something that everybody knows that it is simply rubbish. You cannot ask somebody if he wants something, but if he votes yes, that somebody else pays for it. And I have a number of examples related to that, but I don't want to spend more of your time. I hope I answered the question to the best of my abilities.
Yeah, thank you. Thank you. Yeah. For the moment, it's that's all, and I think that that would be great if you stay with us till the end of our discussion, because there are several also presentations that would be interesting for all of us. And thank you very much, Kyriakos. I hope that you will stay with our project for the continuous, for continuous initiatives.
In any case, I'm always open if anybody wants to bother me. I'm always open to questions. And I would like to conclude my presentation by simply referring you to two studies that I have been in charge of in the European Commission, which have been done by PricewaterhouseCoopers. One is a review of capital expenditure in rail sector of rail projects, the CAPEX study. You can Google Regio Rail unit cost tool, Regio Rail unit cost tool. I will send you the link. I will send you the link. Yes. The thing I would like to say to you is that we are now also completing a similar study for the road sector. Therefore, we have a large toolkit of land transport investment cost estimating tools based on previous projects, which can be used for designing strategies and programs for the future in terms of investment. Thank you.
Yeah, thanks, because we are just in the beginning of the designing of the plans for this sector. So it would be very useful for us to see these recommendations in the beginning, in this start. Yeah. Okay, thanks. Thanks a lot. And the next speaker is Andrew Quinn, University of Birmingham Center of Railway Research and Education. Hello, Andrew. Yeah. Oh, I see your presentation.
Thank you very much. So thank you for the introduction and thank you for the opportunity to speak. My background is, perhaps some of the speakers would describe it as a more technical background. I'm an interdisciplinary scientist who is working on climate change adaptation for railways primarily, but also for other sectors of transport as well. So what I would like to do is talk a little bit about some of the work that we've done with the Union of International Railways on supporting countries and railway enterprises to make adaptation changes for their climate. So you'll all be familiar with some of the challenges that we face at this time to do with the climate, but also to do with security and social policy. And looking at Ukraine and the climate change projections that are given for Ukraine, we are particularly looking at 2 to 5 degree temperature rises on average in the summer. And of course, it's not the average that's important, it's the extremes of temperature which are very important. And particularly worrying for Ukraine and the region is the very large changes, plus or minus 20% changes in precipitation that are also predicted for the summer periods. So these could be particularly intense rainfall increases, or they could be long dry periods as well. There is also a change in the winter forecasts, which would look at greater temperature rises, 3 to 8 degrees, and again, an increase in the precipitation levels. And these wouldn't necessarily be in the types of heavy snowfall that Ukraine is familiar with, but could actually be in the form of sleet and snow, or transitions between freezing and thawing, which become a particular problem for engineering structures. So it's important to think, how do we deal with adaptation in these kinds of situations? This is a figure taken from the IPCC report, the International Panel on Climate Change, and it highlights the difference between mitigation, that is the reduction of greenhouse gas emissions, and adaptation, particularly of engineering structures, I'm thinking of, infrastructure and transport, where we need to change the structures and the systems in order to make them resilient to the changing climate. So we can only mitigate, we can only reduce the changes to a certain degree. We also have to adapt. So these two elements must go hand in hand. And transport has been identified many times as a particularly difficult sector to adapt. And it has very large economic impacts, and it has regional and global consequences because of supply chains and the increasing length and complexity of the kinds of things that we have to transport. So it is important that we consider adaptation, and it's important that we consider the various elements of risk that we are trying to change when we are doing adaptation. So in my risk equation, I think about the hazard, which is the changing climate, the weather conditions, the meteorological variables that are concerned, the vulnerability of the structures and the elements that are in place for the transport system, and also the consequences of any failure of the transport system. And it's really important to start thinking about this in the context of the Ukrainian railway sector. So Ukrainian railways, just like the UK railways and many other railways around the world, has a very long history. It dates back to the early days of railways in the 1850s and has been continually changing throughout history. Even now, it's beginning to work with DB, the German rail group, in order to try and develop its practices and its infrastructure. So it is a continuous changing process, but a lot of the elements of infrastructure which underlie the transport system have been there for a very long time. So we have this mixture of old and new. It's a very extensive network, 22, 25, 27,000 kilometers of track, depending on exactly how you measure it. And as one of the previous speakers mentioned, around about half of that has been electrified to date. So we have this very important infrastructure, which is very embedded within the communities that it serves. And it has a number of challenges before we even start to think about climate change. So we have capacity issues. We have the need to develop a financial model which supports both the social and the economic sustainability of the network. And we also have challenges of infrastructure and rolling stock modernization. So we need to put all of these changes into the model in order to be able to cope with climate change at the same time as dealing with all of these different infrastructure challenges. Now, I mentioned the risk equation because it's very useful in our adaptation process to start thinking about the different elements that go towards making up the risk. The first one is understanding the hazard, understanding the kinds of extreme weather and climate change that we are likely to see, understanding the geotechnical data which underpins the rail system. And of course, these things are well-established sciences. There are projections available. There is information available for that. And for the rail network, we have a long history of safety culture and a long history of financial track records. And we understand a lot of the consequences associated with services running or not running. And therefore, this is another area which we have good information for to some extent. The real weakness that I often find in looking at rail networks is understanding the vulnerability of the different structures that go to make up the rail network. Different design standards have been used. There is a lot of interdependency between different systems, the power system, the signaling system, the railway track, the people and the rolling stock are all elements of this system which have to work together. It is, of course, geographically widely distributed, and it has to its advantage a constant program of maintenance. And this can be a useful vehicle for carrying out climate change adaptation, because it costs very little extra to maintain to a higher standard something that you are already doing, rather than seeking to replace an entire section of the railway line. Now, all of these things are not static, so you need to understand that they are all changing with time, and therefore it is a very complex problem. But it's important that we remember all of these elements as we develop an adaptation plan for the future. So what can we do about it? Well, there are a number of different approaches that have been used in the rail sector. The first is that we can learn lessons from extreme weather events that we have seen in the past. And as the climate changes, those will become more of the normal behavior of the system and of the weather that we see. So we have carried out projects like the Move It project across Europe, gathering examples of how people in the railway sector and other transport sectors have responded to extreme weather events. And we can also look at other places around the world that have those weather events today, so that we can learn what they are like and what sort of effects they have. We can assess the vulnerability by looking at the interdependency of different networks, so the power network, the signaling network, the railway network, the road network. And one of the earlier speakers talked about access, for example, to depots as being very important. And I would echo that importance of understanding where are the consequences of something else failing for the railway system. And we need to consider many different pathways to this resilience that we are looking for. So we can easily imagine replacing equipment, replacing railway lines with other stronger pieces of equipment that are less likely to fail. And that is one method of gaining resilience. But there are many other methods of gaining resilience, and it's important not to forget them when we come to try and develop a plan. So one of them is to develop redundancy, that is to have backups available for things that fail, and plans to put those backup processes into place quickly. Another is to facilitate repair and replacement very rapidly. So expectation of things failing and being able to carry on because you have the ability to recover and repair very quickly already built into your plan. So these are all alternative approaches to resilience which we need to consider in our planning. And they can make a difference to the level of service that we are able to provide on the railway network in the event of disruption. So we built guidebooks for different sectors of transport, including the rail network, looking at different types of extreme weather. So that is available for you to look at. And we also conduct studies looking at the data from the railway and correlating things like faults on the railway with the weather conditions that were happening at the time. And you can begin to see a pattern where particular types of faults with particular types of equipment are very dependent on particular weather conditions. And that begins to give you an early warning of what may be in store for when the climate changes, so that you can see if you're more likely to have high temperatures, then you're more likely to have certain sorts of equipment failing. And therefore you can put in place a plan to improve the specification of that equipment when it's replaced, or to develop some kind of protective approach to avoid its failure from the high temperatures. So it's important that this data, the previous speaker talked about the importance of having good data, and I'd certainly echo that. In some cases where we have data from railways, it can sometimes be very specific. So track faults is one type of failure, but that type of failure can occur for a number of different reasons, which depend on a number of different weather variables. And as a result, it's important to have the depth of data so that you understand the different causes of a particular failure. So that's something that we are working on with the National Railway Network in the UK. And this slide is an example of the work that we have done to identify what we call these analogues. So other places around the world that has similar weather to what we might expect in the UK in the future, so that we can begin to look at how they are coping with their current conditions. And in that way, we begin to get people to work together. And that's a very important part of adaptation planning. So what we have done in the railway industry globally is that we've put together a program called Rail Adapt. Rail Adapt was sponsored by the UIC, the Union of International Railways, and we held workshops in London and Beijing, and we provided the delegates from around the world with a background document on climate change and railways. and we facilitated a discussion about what was important for railway adaptation. And these were the principles that we came up with in that discussion. So we must avoid having processes which duplicate what is already there. So we need to learn from and develop from what is already present. That we need to link together these ideas of mitigation of greenhouse gases and adaptation, as well as disaster recovery and sustainable development. So these are all things that we need to be integrated together in our planning process. We need to think about linking both across organizations and different modes of transport, and also linking within organizations. So where there is a group, perhaps a state-owned group that runs the railways, there will be many different divisions within that organization, and it's very important that they are all involved in the adaptation strategy. And we need to think about this as part of the everyday business of the organization, not just as a special project. Otherwise, it will be forgotten about in the future. So what we came up with was a plan, and this is a process which any organization, no matter how well prepared it already is, or how new it is to adaptation planning, it can engage with this process, which identifies hazards and vulnerabilities and losses that are potentially there from climate impact studies. It can come up forming a risk appraisal and therefore developing an adaptation strategy, which takes into account all of these different elements at many different locations across the network, so that it can identify local issues as well as national ones. And then it can put that into an adaptation plan, which can generate options for improving resilience in different places by different methods. And then it can put those plans into action, and it can review the outcomes of those such that its next round of planning can be informed by what has already happened. All of these steps within this plan, you will notice, are links to other organizations and other sources of information. So it's important that this is a collaborative effort through European programs, through local expertise, through all the different sources of knowledge that are available. And some of the kinds of options that one can be thinking about can be to do with new infrastructure and improving design codes and specifications for the future. It can also be to do with monitoring systems, which can give early warning of problems and failures. It can also utilize the ability of the rail network to do management and maintenance by looking at improving capacity and improving recovery times for equipment and for failures of infrastructure. And finally, for very long life infrastructure, we can put in place monitoring, which can give us good information about the condition of the infrastructure and therefore highlight the weaknesses where interventions are necessary and can help plan renewals of the railway system. So the key messages that came out of the Rail Adapt study, which is available online, you can download the report at the address there, are that we need to encourage cross-sector and inter-agency working. We need to think about strategies that have a number of different options available for different local variations and give a variety of different potential responses. So it's not a one-size-fits-all solution. It needs to be developed in different areas with different priorities. And we need to look at how we monitor and maintain and evaluate the infrastructure that we have looked at, so that this is an ongoing process into the future. So I think I will finish there if I may, and I know we have a discussion session later on, but I'm happy to take any other comments.
Okay, thank you Andrew very much. Actually, I had also some questions about your presentation, but maybe I would just put it aside till the end of the discussion, because it's very deep questions about the indicators of the failure and our possibility to put them together and to analyze everything. So maybe we will need more instructions on this point. Okay, thank you. Will you stay with us? Yeah?
Yes, yes, I will.
Okay, thanks. So we'll have more questions in the end of the discussion. And the next speaker is Kivan Isevs. Oh, I'm sorry to, maybe I misread your surname. And roads, highway and bridges, traffic and environment, Netherlands. Are you with us? Please?
Yes, can you hear me?
Yes, we can hear you.
That's good. And I can share my screen, I suppose.
I'm sorry, how to spell your second name properly?
Oh yeah, it is in Dutch. It's Kees van Muiswinkel.
Okay, thank you very much.
I can understand, but I'm sure I can't pronounce your name properly. So problem. So I'll try to share my screen.
Yeah, please.
Yeah. Can you see it?
Yes, it's okay now.
Okay. Yes, so let's see. Oh, oops. There's. Yeah, so, well, thank you very much. Very interesting content. Before I haven't been able to follow everything also, and I hope the connection is okay because sometimes it fell away for me. So, yes, I'm going to tell you about the climate stress test of our Dutch highway system. Actually, I work for Rijkswaterstaat, which builds, maintains, and manages the highways in the Netherlands, but also the waterways and also the water systems. So, and it's all about, so it's also water quantity, water quality, shipping, and obviously the roads. And I'll give you a short introduction. I'll tell you about the stresses of the highway. And tell you what we have done so far with the results of the stress test. So here you can see some effects of climate change on our highway system. So we look at the effects of extreme rainfall, which can cause erosion, as you can see, but also water on the road obstructing traffic. Drought, we have experienced long periods of drought the last few years, and it can lead to more soil subsidence. We have a very soft soils in the Netherlands, which are susceptible to soil subsidence, but due to drought, it can be increased, which can cause damage. Drought can also lead to less water in the rivers, which means less transport, which means more transport on the road. It also can lead to more fires along the road. Heat is another aspect. One of the problems we had last year is that due to heat, bridges that open for ships can get stuck, which is both a problem for the shipping, but also for the roads, as you can imagine. And in the end, also, we look at the effects of flooding, which can be flooding both from the sea, but also from the rivers due to higher discharges because of climate change. And we have a high standard of levees, etc., but due to climate change, we can get more vulnerable. So these are all effects we have looked at for our roads. And as I said, it can mean both short-term effects, like water on the road can cause a problem, can cause traffic jams, but you can imagine if you have long periods of drought every year, this will mean this can cause a modal shift from more shipping more to the road, which can be a problem for the roads. But also at the same time, it's very uncertain, as you know. Because of COVID, for example, we have had a lot of less traffic, and that's just an example of how uncertain the future is. So that's also a challenge to how to deal with uncertainty when you deal with climate change. Well, our stress test follows from our climate change adaptation policy. We have a Delta program looking at protection against flooding from the sea, but also we have said the Netherlands should be climate resilient by 2050. And to that end, by now we need to start to take measures, both in our policy, but also in all our actions, which can be building, maintaining, etc. I show you a diagram, and as you can see, we have and I'll add some. We have done the stress test that was done almost 2 years ago now. And right at the moment, we're in the process of having dialogue. So we talk with stakeholders about the results of stress test, and also, okay, what measures do we want to make? What measures do we need to take? So we started in these dialogues last year, and we're carrying on with that. Not only talking with our own stakeholders, there are regions who actually build the roads and maintain. And we show them the results and talk with them. Well, do they recognize the vulnerabilities, but also what sort of measures should we take? But also we talk with our ministry, which is actually, we work in order of the ministry. So we manage the roads for the ministry, and we need to have discussions. So what would this mean for extra costs, for example? And also we talk with external stakeholders like water boards, municipalities, provinces who deal with other roads, for example. We need to look, well, do we have common challenges, and can we work towards a common solution for climate change adaptation? And in the end, so we're working towards, okay, what sort of measures, what is the implementation plan? And we need to talk about ambition. So we're actually right in the middle of this process at the moment. So in our stress test, we looked at different vulnerabilities. I just told you about that. So we look at the effects of extreme rainfall, droughts, flooding, and also heat, for example, all these aspects. So we assessed the vulnerability of our roads. With those results, we have integrated in our so-called climate effect atlas. You can see Dutch here, but basically it's the results of our stress test. We made them interactively available. So everybody who wants to know how roads are vulnerable in their region, they can sort of zoom in and look at the different effects and do it interactively. And so that's a very nice tool, I can say. For example, also our railroads company in the Netherlands have the same ProRail. And they have made the same sort of stresses also interactively available, which is very helpful when you want to talk about what measures do you want to take. So I give you some examples of the maps we have. For example, we have mapped, well, where are the vulnerable bridges? The other thing is, where are our roadsides vulnerable to fires? You can see on the map here that in more woody areas, as you can expect, the roadsides will be more vulnerable to fires. And that's so that we can think about, so do we need to manage our roadsides in a different way? Do we, for example, we need to cut the grass more often? Well, there's lots to say about that, but anyway, that's one aspect we're looking at. Now I hope. Yes. Next map, highways. Here you see, for example, a map which shows what are our repair costs when we have pluvial flooding. You can see that can differ on different stretches of roads. Next slide is, for example, I told you about the soil subsidence. We have, for example, large parts that have a lot of peat. And well, soil subsidence is something that's been happening for ages, but due to droughts, it can be increased. And there you can see the map where you can see which stretches of the road are vulnerable to that. Next slide. Well, 60% of our country is susceptible to flooding, so below water level or below sea level. And obviously we have a very high standards of high water protection, but still then due to climate change, the risk of flooding can increase. And as you can see, when the flood happens, large parts of a road will be flooded, and the impact will be very high. So that's something we're looking at. And this sort of maps helps to see, well, where would you want to invest, and where, for example, could you take measures for with an eye on evacuation or the repair phase. And with all these results, we have. So I've told you about the dialogues with stakeholders, and we work towards an action perspective and measures. So we offer, for example, we have also developed lists of possible measures to take for roads. For example, for that we used the results of the CEDAR project, ROADAPT, which has some list of possible measures, but also we've done some more development on that. And in these dialogues, for example, regional dialogues will work towards, for example, to a top 10 of hotspots. So what are the most important climate risks? Which are the hotspots? Also, we talk about, well, what level of resilience do we think is acceptable, which is not a very easy question to answer, I can tell you. Also, we talk about the measures. And here you can see an example of the way we look at it. So you can see on the bottom, low probability of occurrence, on the top, high probability, also small impact and large impact on the right, a big impact on the right. And you can, for example, some water on the road, due to extreme rainfall, the probability is quite high, but the effect, because it will go away again, you know, the water will run off from the high, for example, so the risk will not be that high. But for example, bridges that do not come close, you can imagine if the bridge doesn't close anymore, the traffic, you get a huge obstruction of traffic. So that's something that this sort of diagrams show the importance, where do we need to take measures. But also we look at the low probability and high impact things like flooding. So the probability is very low due to the flood measure, also the high water protection we have. But if it happens, the damage can be immense, as you can imagine. So that's something we are really keen on to deal with. This just to show you the way we look at these risks. For this assessing risks, we have, for example, used the Ramsheet model, which is from a model that we also use for asset management. So R is reliability, A is availability, maintainability, but also, for example, effects for health or safety. And so we want to weigh all these effects. And you can imagine that due to climate change, the probability of certain climate effects can increase, and also the risk can increase. So this sort of risk matrix can also help us to see, well, where would you want to take measures? And all these things are not done only on paper, but also we discuss with all sorts of experts, also, for example, asset management experts. And I think the great challenge at the moment is, you know, it's not very complex to think about measures you can take against for resilience, but the thing is, how do you actually how far do you go when taking measures? Because you don't have unlimited budgets, and I'm sure it's the same in your country, that you want to know, okay, what do you accept? For example, some water on the road which obstructs traffic for an hour is not a big problem, so you may accept that, but you don't want to accept if the road is obstructed for weeks or even months. So that's the way we need to think about it. I'm going to click through this. And so in the end, we work towards possible measures. We want to integrate that into our performance management system. Also, we have a lot of our infrastructure is from the 50s or the 60s or the 70s, and lots of it needs to be replaced by now. And that's, we need to think about, when we replace that, do we want to change design because of climate change? And in the same time, we don't only want to look at our roads, but also in the context of the environment of the other stakes. So that's really important to take integral measures. Well, that's what I would like to tell you about now, and we'll be happy to answer some questions later on if needed. And as you can imagine, there's lots to say. We have quite a large team working on this. So yes, I'm happy to take questions later. Yes, shall I stop sharing? That was it.
Yes, Kees, that was actually a great presentation, and there's some questions from the group, and the first question is how to get your presentation, and can you send it please to us, because there are a lot of useful information and tables that we can maybe just approximate to our situation.
Yes, sure. I have made a PDF version of it, and I will send it to you.
Yeah. Okay. I will send to the chat the email just for communication and for this presentation, if it's possible to get it. Okay. Yeah. And dear friends, anybody wants to ask a question right now? Not at the moment. Maybe people just making some thoughts together. Okay, thank you very much. Please stay with us. And we have one more, no, we have two speakers in our panel. And airports, Rachel Burbridge, Eurocontrol. Are you with us, Rachel, right now?
Hello. Yes, good afternoon. Thank you.
Hello. So it's nice to see you. And can you start, please? Right now, the stage is yours.
Thank you very much. So I shall just share the presentation. Okay, can everybody see those slides now?
Yes, it's
excellent.
Right now. Yeah. Okay.
Great. So thank you very much for the invitation and the introduction. It's really a pleasure to be here this afternoon. So I'm going to start looking at this from the perspective of aviation, or more specifically airports. And this is, there we go, an overview of what I'm going to talk about this afternoon. So I'm going to just give you a very quick introduction into who Eurocontrol are and why we're looking at climate change adaptation. I'm going to talk about some of the main climate change risks for airports, first thoughts on what the impacts for Ukraine's airports might be, and then I'm going to talk about climate change risk assessment and adaptation planning. And I realize previous presentations have already talked about that quite a bit, so I'll try and put that in a bit more of an aviation context. Okay, so Eurocontrol is the European Organisation for the Safety of Air Navigation. We are an intergovernmental organisation. We have 41 member states, and I'm very happy to say, pleased to say, that Ukraine is one of our member states. And our main objective is to support our member states in safe and efficient operation of the pan-European air traffic management network. And we do other things, for example, sustainability, performance monitoring. And since 2008, we've been looking at climate change adaptation. So we first identified the impacts of climate change as a risk for the aviation sector as part of our 2008 Challenges of Growth work. And since then, we've produced a series of studies identifying the potential impacts of climate change for European aviation and looking at how to address those impacts. And these can all be downloaded from our website if anybody is interested, or I can send direct links. And in June, I'm pleased to tell you that we're hoping to publish a new study which will try and quantify the potential impacts of sea level rise, storms, and changes in traffic demand for the European aviation sector. So these are some of the potential impacts of climate change for airports. It's very important to note that how climate change will affect airports will really vary according to the characteristics, the individual specifics of an airport. So that will depend on their local circumstances, their geographical location, what the base climate is that's changing, but impacts can include operational risks, such as increased delay or cancellation of flights because of disruptive or extreme weather, storminess, risks to the airport infrastructure, for example, flooding, heat damage, or loss of ground transport links, or business risks, such as an increase in cooling demand because you've got more extreme heat days, or you might see climate-driven changes to demand patterns. So there's really a wide range of risks that can impact airports, but it really will vary according to the airport's individual specifics. And so it's really important to carry out a climate change risk assessment for each location. So this is the international airports in Ukraine. I wanted to get a feel of where the airports are and what kind of risks they might have to deal with. And you can see they're in a range of locations. Some are coastal, some are further north. And this will really influence the impacts that they might expect. And then Andrew touched on or spoke about this in his presentation. These are temperature forecasts produced by the European Environment Agency. And you can see that under a medium warming scenario, on average, Ukraine might expect around 2 to 3 degrees centigrade of increased warming by the end of the century. And under a higher warming scenario, an average of around 5 to 6 degrees centigrade. But as Andrew also said, these averages hide the extremes, and it's really important to focus on the extremes as well, because they're what creates the biggest challenges. Also possibly to say these are forecasts out to the end of the century, and so that is quite far to be looking. And for an airport risk assessment, I think we really want to be looking more around 2040 or in them out to 2040, maybe 2050. But this gives you the sort of an idea of what we might have to deal with. And so you might have to increase cooling requirements because you're getting higher temperatures. Or something else that was touched on earlier, you might get more days where the temperature is hovering around 0 degrees. So you've got these issues with freeze thaw, and also you get a lot more freezing rain around those sort of temperatures, and that has quite a big impact on operations. So this is the chart for precipitation. And again, you can see sort of geographically, you've got quite big differences here where you're expecting quite a big increase in precipitation in the north of the country and a decrease in the southeast. And again, just to stress, these are longer term projections, but it gives you an idea of the kind of issues you might want to start thinking about. For example, have you got is your drainage system capacity going to be big enough to deal with an increase in heavy precipitation? Have you got electrical infrastructure which might be inundated, for example? Or what about your ground transport links? Are they at risk of flooding? And again, this is only a high-level indication. It's really important to do a full climate change risk assessment for each airport. And we will talk about that in a moment. But first, just wanted to touch on traffic growth. So we are obviously in very difficult and challenging times at the moment, but after COVID, we do expect traffic growth to pick up again. These are forecasts that were done before COVID in end of 2018, but we do expect to see these kind of growth levels returning. And you can see that Ukraine is expected to have one of the highest annual traffic growth rates in Europe. And this is relevant to climate adaptation for two reasons. Firstly, when an airport's operating at or close to capacity, the time it takes to recover from a disruption, such as an extreme weather event, disruptive weather, intense storm, is much longer. Therefore, any potential increase in weather-related disruption is likely to be further exacerbated. This is something Andrew touched on again. Because you're operating close to capacity, you haven't got the redundancy in your system to be able to accommodate the backlog of traffic. And perhaps secondly, because building climate change resilience whilst managing a significant increase in traffic is really a double challenge. And so it's better not to treat the two issues in isolation, but to look at them in parallel. And in particular, for example, if it's important to note that developing resilience to climate change as part of ongoing operational and infrastructure improvements can be the most efficient and cost-effective way to achieve this. So if you're taking measures to develop an airport to accommodate greater numbers of passengers and flights, then climate resilience should be viewed as an integral part of this. Okay, so moving to risk assessment, we have talked about this quite a bit already. I'll try and put a bit more of an aviation context to it. But basically, as the other speakers have said, what you want to know is what could happen, how likely is it to happen, and what is the impact if it does happen. So a few important high-level things you might want to think about is how is the climate going to change in the location where the airport is. We looked at European climate forecasts a couple of slides ago, but you really need to get good quality local climate forecasts at as high a level of granularity as you can, if possible. So working with the local Met provider. It's also important to think about who's actually responsible for the assessment and who needs to be involved. So although we're talking about climate change, it's not just an environmental risk, it's an operational, safety, mobility, business risk. So you need to make sure that you've got all of the relevant parties involved. And perhaps one key point is not to consider the airport in isolation, because there may be some key risks that aren't under the airport's control. For example, ground transport access or utility supply. Can you ensure the access in the event of a disruption, and can they be maintained if there are longer term changes such as sea level rise or temperature increase? So if we've talked about getting local Met data already. We've talked a little bit about building the team, deciding who needs to be involved, making sure you've got the right people from across the airport and externally. And I think another thing that's really important is to get senior leadership commitment. So right from the beginning, so as to legitimize the process, and also to provide support with getting human and financial resource. Then you need to identify the risk assessment methodology that you're going to use. So you might use the airport's existing risk assessment methodology, or you might use a climate risk assessment methodology that's been developed by another organisation. And very importantly, you need to work out if there's any legislation that needs to be complied with. So once you've identified your risk assessment methodology, then you need to use that to identify any potential impacts and vulnerabilities. And in particular, you might want to focus on any critical safety and operational risks. So as we mentioned before, you need to know what's going to happen or what could happen, how likely is it, and what are the potential consequences if it does happen. So when you've identified which climate impacts the airport might experience, maybe it's higher temperatures, stronger storms, combination of the both. You need to identify how likely that is and how and to what extent each element of the airport might be affected by that. So one thing you can do is develop a risk matrix. We looked at some other examples of these with previous speakers, and this is how you build your overview of the vulnerabilities that you might need to adapt to. And then once you've got that overview, then you can start to develop a climate adaptation plan and identify a set of actions. I think, as was mentioned in the last presentation, there might not be resources, well, there almost certainly won't be resources to do everything. So you will need to prioritize critical elements, and we can touch on that a little more in a moment. And also you will need to periodically review the plan because the extent and timing of impacts might change. So you need to keep a little bit of flexibility. And above all, I think this was touched on in previous presentations as well, the collaboration between the people, between the different departments, making sure everybody's talking to each other and everybody's on the same page is really important. Okay, so when you're developing your adaptation plan, there are a number of sort of questions to ask. And of course, the eventual decisions that are made will be highly dependent on local circumstances, the airport's business model, for example. But probably the key question is how and when to act. You have to find the balance between under adaptation and over-adaptation, particularly with infrastructure where you might have less flexibility to change. So you also need to think about, we often say that preemptive action is beneficial and cost-effective because it reduces both costs and damages in the longer term. But it's important that any preemptive action is based on best available information so that you avoid excessive or inappropriate maladaptation. And so this is why you need your risk assessment. That's why the risk assessment is really important. Then you have to weigh up the cost of what you want to do versus the level of resilience it will bring. It's probably going to be completely unfeasibly expensive, if not impossible, to achieve 100% resilience for an airport to climate change. And so you will need to make some decisions as to what level of resilience to achieve. So as was touched on previously, lower levels of adaptation may be cheaper, but you'll have less resilience and possibly the measures will last for a shorter lifetime. But for more robust adaptation, new measures, you might have a greater level of resilience, but unfortunately at a higher cost. So this is when we need to think about criticality. So if you're not able to do everything, which are the most critical areas where adaptation action is required? What is the impact if those areas are unavailable or damaged? For example, if your runway is out of action, then you can't have any arriving or departing flights. So you need to, one element of criticality is making sure that you have the measures in place to be able to maintain runway operations to the extent possible. And also you need to balance that what you want to do against the human and financial resources that you have available. And then finally, as climate change may happen differently, it may happen more quickly than projected. Or adaptation measures that you've implemented may not be quite sufficient. They may need to be enforced or altered. So plans should ideally be flexible and reviewed at regular intervals. And then just finally, a little bit about what kind of adaptation measures you can implement. Well, as we've touched on previously, airports are so individual. And basically, if you've seen one airport, you've seen one airport. So this really does have to be a local decision. It's going to be very specific to the characteristics of the airport. But one example is if the airport is in an area at risk of sea level rise, you might decide between some safe level of inundation, building sea defences, and then perhaps finally, as a last option, relocating the airport. And this is probably going to be based on some kind of decision-making tool, such as a cost-benefit analysis. And so the eventual outcome may be different for different airports because the inputs into the decision will be different. Or perhaps if you're expecting more frequent and stronger storms, if, for example, a 1 in 100-year storm is going to become a 1 in 20-year storm, then you might want to reinforce your infrastructure. But again, to what extent you do that will be an individual airport choice dependent on your risk levels and how much risk you're prepared to take. But then perhaps the one thing that is common to all airports adaptation planning is the people. For example, a contingency plan for an extreme weather event is reliant on the people that implement it. And you can have a really good forecasting capability, but the people working, the people making the operational decisions need to know how to transfer that information from the forecast into making an operational decision. And so for that reason, I would say that soft measures such as training, definition of best practices, coordination, can be just as important as the sort of the harder and more expensive measures. Okay, so then this last slide is really just some resources that you could use. The ICAO Climate Adaptation Synthesis is something that we developed in the ICAO Climate Committee on Aviation Environmental Protection, and that's a fairly comprehensive overview of the climate impacts that aviation is a bit broader than just airports could experience, and adaptation measures that could be taken. We are currently working on some guidance documentation to support that, which we hope will be published early next year. But all of the resources on there will be really useful to support adaptation planning for airports. And in particular, perhaps looking at adaptation plans produced by other airports to get an indication of what they've done, how they've done it. I think in Europe, perhaps the French DGCA have produced a good overview and a risk assessment methodology. In Norway, Avinor have done lots of good work, and several of the UK airports. But there are also good examples from further afield at Brisbane, San Diego, Hong Kong, Singapore. And that can also tie back into what Andrew said about getting ideas of how other areas of the world that are already dealing with some of the impacts we might expect are handling those issues. Okay, so I'm going to end there, and of course available for questions whether people want to ask them now or later during the discussion. Thank you very much.
Oh, thank you, Rachel, so much for your presentation. It's actually very interesting. We also ask you to share these links with us. Please send it through email. And dear friends, do you have a question to Rachel right now? Okay, I have one question. Maybe everybody know about that, and maybe not. But I know that in airports there are very huge hydrometeorological stations that do monitoring process. And can you tell us, Rachel, if this information, I mean all the data, hydrometeorological data that is collected for airports, does it have the common center for analysis, maybe some kind of association, or do you give this data to ESA or NASA center to analyze and to make some prognosis or assessment of the future, for the future and for the past period, maybe 5-10 years? How do you collect this data?
Yeah, that's a good question, because it's surprising actually. An awful lot of airports do function as met stations, collecting meteorological data for local and national met providers. I think it varies from airport to airport how much the coordination between the Met provider and the airport is, and how much of that information is directly passed. But then actually a lot of academic organizations take that data to do studies, to do analyses of past impacts. For example, how the weather has been changing or the climate in a particular airport. And then more and more, they're sort of starting to extrapolate that. So yeah, I think it varies, but it's obviously a really, really good source of metadata to use for analysis.
Yeah, I know that the most modern systems for analysis put it to the airport collecting data. Okay, thank you, Rachel, so much for the presentation.
Thank you.
We have, stay with us, please. And we have one more speaker.
Yes. Olga, if you'll allow me, I think I would like to reiterate something that both Andrew and Rachel said is, first of all, the need for collaboration. No technical aspect has all of the information. It's really important to open and listen to what other experts are saying. That's number one. Number two, I think we're all emphasizing the need for data, but you're never going to have perfect data, right? As with all research and all analysis, you need to know when to cut off and to make a decision. And it's better to make a decision that allows you to move forward and reduce impacts now for certain things, even if it's not 100% perfection, which you're never going to get, but allows you to move forward, but at the same time, continue to improve your ability. We are in a situation where all infrastructure has to be looked at on a rolling basis. which is a bit different from how we've all looked at infrastructure in the past or tended to look at infrastructure. And we just need to take that into account and remember, you're never going to get 100%, as Rachel said, 100% resilience or 100% climate proofing, and you're never going to have 100% perfect data. This is where technical expertise and technical understanding plays a role, where expertise plays into defining the options that decision makers have. And lastly, Rachel didn't mention this, but I think it's worth considering. It's not directly for airports, but airplanes. Airplanes collect a lot of data, and with a reduction in travel in the last year due to COVID, there are going to be gaps for this period of data collection, because the amount of monitoring systems obviously was reduced since not as many planes were in the air. So we all have to take those kinds of things into account as well.
Mm-hmm. Okay, thank you, Rachel. Oh, thank you, Frod. Thank you, Rachel. Both of you, you're great, and please stay with us because we need more information about these monitoring systems and how to use this data, and maybe how to make this great scenarios for the future, for the nearest future, and for the long-term future also. Thanks, and we have one more presentation for today. Велосипедна та мікромобільна інфраструктура, Ірина Бондаренко та Богдан Лепявко, ПРООН. Любі колеги, я вас прошу, це дуже важлива для нас презентація, тому що вона вже дуже наближена для України. Це розробка власне проекту ПРООН. Тому дякую вам за вашу участь і, будь ласка, сцена ваша.
Дякую. Я розшарюю тоді презентацію. Отже, мене звати Ірина Бондаренко і мій колега Богдан. Ми працюємо зараз консультантами програми розвитку ООН.
Якщо можна, трошки звук підняти. Так,
як чути зараз? Бо
краще.
Дякую. Отже, ми працюємо зараз консультантами для програми розвитку ООН з розробки національної велосипедної стратегії і включення питань мікромобільності до цієї стратегії. Під мікромобільністю зараз йдеться про всі індивідуальні легкі способи пересування, які не вимагають надмірного використання енергії і використання, власне, електросамокати, гіродошки, моноколеса, все, що ви можете уявити, що на чому можна пересуватися швидше, ніж пішки. Прошу, наступний слайд. Чому це важливо, окрім того, що було сказано вже неодноразово під час сьогоднішніх презентацій, крім того, що в Україні зростає і, в принципі, не сказати, як в єС величезний відсоток викидів парникових газів саме від транспорту, але все одно цей відсоток доволі великий, це останній раз було 11%. Але окрім всього цього, є також проблема безпосередньо у містах, де проживає 70% населення України згідно з останніми даними, і в великих містах, таких як Київ і інші великі міста України, теж підключаються до цієї сумної статистики. Громадський транспорт уже є перевантаженим. 110-130% – це був показник для Києва. Все збільшуються затори, і ми почнемо розуміти, що навіть маючи такий низький відсоток використання автотранспорту, навіть сказати не відсоток, а кількість автомобілів у власності на 1000 населення, на душу населення, ми маємо менше, ніж в Європі, про що було згадано сьогодні, але навіть при цьому ми маємо затори значно вищі, ніж в Європі, і громадський транспорт у нас вже перевантажений. Тобто фактично нам треба думати про якийсь третій спосіб, яким чином ми можемо, не збільшуючи використання приватного автотранспорту для цих 70% населення України, і яким чином ми можемо зменшити, забезпечити ту саму кількість поїздок, не збільшуючи використання автомобільного транспорту. І, власне, велосипедний транспорт, мікромобільність може зайняти певний відсоток цих поїздок. І на наступному слайді я зробила кілька скріншотів, як виглядає розподіл поїздок за видом транспорту в різних містах. Перші два, Берлін і Відень, мені здаються доволі схожими за кількістю населення і розміром на Київ, скажімо. І ми можемо бачити, що жовтий – це велотранспорт. В Берліні можна досягти 18% поїздок, здійснених велосипедом було досягнуто, а у Відні – 7%. Для менших міст цей відсоток може бути навіть більшим, такі як Франкфурт, Хельсінкі і Дрезден. Вони можуть мати, Дрезден, навіть 20% поїздок на велосипеді. Ну і, власне, останній слайд ми бачимо – це Львів. У Львові було лише 2%, це дані за, здається, 2017 рік. Тим не менш, ми очікуємо, що вони зростають, цей відсоток поїздок. Але це слайд, власне, показує, скільки поїздок, яку величезну кількість поїздок, в принципі, можна забезпечити, не використовуючи ніякої енергії, не викидаючи жодних викидів. Є три основних групи перешкод для велосипедистів, які пов'язані безпосередньо з наслідками зміни клімату, які можуть зупиняти велосипедистів від того, щоб використовувати велосипед. І деякі з них пов'язані з змінами клімату, деякі з них пов'язані з недосконалістю наявних державних будівельних норм або інших документів, про які пізніше скаже Богдан. Перше, про що я хотіла би наголосити, про що не дуже часто розмірковують наразі, намагаючись зробити величезну кількість велосипедних доріжок, але менше приділяючи уваги, це покриття цих велосипедних доріжок. Праворуч ми бачимо кілька слайдів, які є з Кам'янця-Подільського і Тернополя. Дуже часто, дуже популярним є використання плитки для велосипедних доріжок, яка в дощову погоду стає дуже слизькою і небезпечною для використання велосипеда. Це дуже популярно. І це навіть стосується не лише велосипедних доріжок, а й пішохідних тротуарів також, і зменшує, точніше, не те, щоб зменшує можливість використання велотранспорту, а навіть, я би сказала, збільшує травматичність при використанні велотранспорту. Також плитка має здатність, якщо вона неправильно вкладена, підніматися і також підвищувати небезпеку і для пішоходів, і для велосипедистів. Власне, це момент, який потрібно враховувати при розробці і врахуванні нинішніх документів, зважаючи на те, що буде більше злив, буде більше, якщо ми хочемо все ж таки велосипедиста пересадити більше людей на велосипеди, то необхідно обов'язково враховувати питання якісного покриття для них. Інший момент – це зливова каналізація. В Україні доволі часто приділяють менше уваги питанню зливової каналізації, що захламляє узбіччя доріг і забирає той простір, який міг би бути використаний велосипедистами. Часто також решітки зливової каналізації можуть бути повністю відсутні. Це є проблема, яку навіть важко сказати, на якому рівні вирішувати, тому що вона, звісно, на місцевому рівні вирішується. Але якщо є якісь моменти, які можна вирішити на національному, це має бути вирішено. Принаймні, це має бути усвідомлено як важливий аспект розвитку велосипедного транспорту і перешкода в даному випадку. І третє – це доволі часто у нас і пішохідні маршрути, і велосипедні. Вони прокладаються так, що не вистачає дерев і тіні загалом для руху на велосипедах. Це все зупиняє людей від використання велотранспорту в спекотні місяці літні. І, звісно, дуже важко створити тінь дуже швидко, але це необхідно враховувати, бо ці два приклади українських міст, вони не є привабливими для використання велосипедів. Власне, всі ці пункти, про які я сказала, і більше також, вони враховані в Національній велосипедній стратегії України. Наразі це чернетка. Власне, я показую перший драфт стратегії, уже готовий і переданий, майже переданий завтра в Міністерство інфраструктури. Зокрема, у вигляді змін до державних будівельних норм в питанні, щодо питань покриття для велосипедної інфраструктури і деяких інших. Про дерева там нічого не йдеться. І для того, щоб ми просто розуміли, як виглядає ця велосипедна стратегія наразі, є дві головні цілі, вони позначені ліворуч. Це зменшення смертності велосипедистів у ДТП і збільшення частки поїздок на велосипеді до 10% по країні. Я показувала кілька слайдів, 10 по країні – це можливо. І це було розраховано спеціальними формулами на основі того, що, скажімо, 5% поїздок буде здійснюватися велосипедом у великих містах. Це мета стратегії до 2030 року. 10 у містах середнього розміру, 15% поїздок в малих містах і в громадах. І кілька напрямків основних, про які йдеться в цій стратегії, це створити безпечні умови для пересування на велосипедах у містах та між ними, що є найбільшою перешкодою. Наявність цих небезпечних умов є наразі найбільшою перешкодою для пересування на велосипеді. Наступний пункт – це створити умови для мультимодальності з урахуванням велотранспорту, оскільки не всі поїздки можна здійснити велосипедом від початку і до кінця, то пропонується також на деяких ділянках підключати можливості для пересадки з велосипеда на електрички, на громадський транспорт і назад, тобто мають бути перехоплюючі велосипедні парковки або можливості для перевезення велосипедів у або зовні громадського транспорту. Наступний пункт – це створення фінансової можливості для купівлі і використання велосипедів. Зараз є певні обмеження, які пропонуються. Ця стратегія пропонує кілька рішень, як їх можна уникнути. Збір, аналіз даних, про це сьогодні говорили. Так, в Україні не вистачає даних і аналізу даних, власне, навіть Model Split, а в Україні ці дані не збираються і не рахуються, ніхто точно не знає, скільки ж в Україні поїздок здійснюється на велосипеді, крім кількох міст. І тому важливо почати це робити. І створення позитивного іміджу велотранспорту – це останні розділи, там пропонується кілька рішень. Я прошу мого колегу Богдана продовжити.
Дякую, Іро. Дозволь, будь ласка, я на свою презентацію переключу, щоб я міг
як тобі зручно
нею керувати. Отже, продовжимо. На цьому слайді ви можете бачити, що насправді багато міст України вже роблять певні кроки для створення велосипедної інфраструктури. І це міста, в яких вже є якісь затверджені плани, стратегії, концепції по розвитку велосипедної інфраструктури для засобів мікромобільності. Ну і ми можемо бачити, що це дуже добре корелює насправді з фактично наявною інфраструктурою. І тут ми можемо бачити на цьому слайді довжину окремої велосипедної інфраструктури в тих населених пунктах, де вона, власне, вже є, і що це от корелює доволі добре з тим, що де ці програми якісь є. Ну, це до того, чи потрібна ця велосипедна стратегія. Мова йде про те, що якщо стратегія буде якийсь план передбачати дій, то, звичайно, це буде втілюватися в інфраструктуру, в фізичні можливості цієї інфраструктури і скористатися. Ну, от як ми можемо бачити на прикладі міст, де це вже є. Щодо нормативних актів, уже останні кілька років іде така трансформація українських нормативних актів для того, щоб велосипедна інфраструктура почала відповідати тим вимогам, про які казала Іра. І от, зокрема, вже були змінені державні будівельні норми вулиці та дороги населених пунктів, державні будівельні норми автомобільні дороги. Це в 2008 році ці нові норми вступили в дію, і зараз інженери, проєктуючи нові дороги або там реконструкції, капітальні ремонти вулиць у містах, вони вже беруть до уваги ці норми, де передбачено велосипедну інфраструктуру. В 2019 році було прийнято ДСТУ відповідний, а в 2020 році він вже також вступив в дію, тобто це більш детальне роз'яснення для інженерів, як цю інфраструктуру організовувати. Зміни до правил дорожнього руху, деякі було також прийнято останні 2 роки, але частина ще в роботі, і сподіваємося, що також Кабінет міністрів в найближчий рік-два затвердить ті зміни, які є критичними для того, щоб користування велосипедом і засобом мікромобільності в містах стало більш комфортним і безпечним. Верховна Рада також у першому читанні прийняла вже закон про легкий персональний транспорт, у якому буде дано визначення, зокрема, засобам мікромобільності. а також багато моментів регульовано, які зараз є невизначеними. Сподіваємося, що цей закон буде з відповідними правками прийнято в другому читанні також у цьому році, і багато дірок нормативних ним буде закрито. Ну і те, що згадувала Ірина, національна велосипедна стратегія, яка буде це все збирати, яка визначить всі проблеми, які є зараз, і допоможе такий створити екшн-план для їх розв'язання у майбутньому. Ну, от, власне, перелік цих проблем можна на цьому слайді побачити. Тобто зараз засоби мікромобільності взагалі відсутні будь-де в українській нормативній базі. Правила дорожнього руху потребують багатьох правок. Також є проблеми з бюджетуванням, тому ну, річ у тім, що створення велосипедної інфраструктури порівняно дешеве. Ну, наприклад, для Києва створення велосипедної мережі для всього міста буде порівняним з будівництвом однієї транспортної розв'язки або ж всього однієї-двох станцій метро, ну, але при цьому дасть можливість величезній кількості людей отримати доступ до цих нових, зручних у багатьох випадках транспортних засобів. І проблема в тому, що не завжди місцева влада розуміє цінність, або навіть розуміючи цінність, вони просто не можуть розставити пріоритети, тому що ніде не вказано, чому саме вони мають, на яких підставі вони мають будувати цю велосипедну інфраструктуру, і який пріоритет це має мати в місті. І наступна проблема – це також громадська думка. У нас досі доволі сильний стереотип, особливо у великих містах, що велосипеди та самокати – це більш щось молодіжне або спортивне. І особливо в маленьких містах, де структура муніципальної влади не надто розгалужена, то дуже часто питання велосипедної інфраструктури відносяться взагалі до компетенції відділу молоді та спорту, а не транспорту. Ну, а молоді спорту немає, наприклад, у себе спеціалістів, які можуть ну, навіть читати креслення якихось проєктів вулиці, давати фахові коментарі, чому там потрібно тим чи інакшим чином облаштовувати велосипедну інфраструктуру. Ну і щодо потенціалу, ми його, ну, от розбиваючи теж стереотип, наскільки в Україні взагалі велосипедний та мікромобільний транспорт може мати якесь майбутнє. Ми це побачили от під час пандемії у 2020 році, коли під час карантину було обмежено рух громадському транспорту у багатьох містах. Ну, і от, зокрема, в Києві за цей рік, лише за один рік, в 2,5 рази зросла кількість користувачів велосипедів. Також суттєво зросла кількість користувачів засобів мікромобільності. Важко сказати наскільки, тому що тут щороку з'являються нові компанії, і кількість цих засобів просто дуже стрімко росте, тому порівнювати поки що дуже важко з попередніми роками, але візуально видно, що їх вже дуже багато. Ну, зокрема, в минулому році було десь 20% від кількості велосипедів вже становили теж поїздки на засобах мікромобільності. І щодо велопрокату, от в Києві вже кілька років функціонує велопрокат BikeNow, і він в кінці 2020 року опублікував дані, що вже 160 тисяч користувачів у них зареєструвалося. Ну, це більш ніж 5% населення Києва, тому там от у нас в стратегії був, Іра показувала, що для великих міст там такий показник передбачено, що 5% поїздок на велосипеді щонайменше. Ну от в Києві вже 5% людей, зареєструвавшись в цьому сервісі, по суті, декларували свою готовність сідати на велосипед. Можливо, зараз вони не їздять щодня, але це от зумовлено тими проблемами, які зараз є. Але вони принаймні готові це робити. Ну і щодо мікромобільності, то вже 4 компанії оголосили вихід на ринок в Києві 2021 року, тому їх кількість теж, безперечно, буде лише зростати, і тому потрібно також врегульовувати питання їх використання. Дякую.
Колеги, дуже цікаво було вас слухати. Ну, власне, хотіла від себе що додати. Я маю зізнатися в тому, що я така незграба, я не вмію їздити на велосипеді. От, і, чесно кажучи, розуміючи, що зараз ця тенденція розвивається, дуже було б слушно взагалі якісь передбачити заходи, щоб можна було людям вчитися взагалі їздити. Тому що я виросла в великому місті, тут не було такої потреби. І хотіла звернути увагу на те, що, от, наприклад, в Чехії там є шикарний такий як взірець, на який можна було б орієнтуватися. Я думаю, що ви про нього знаєте, і ви його бачили, дивилися. Там є велотраса, яка побудована через всю країну. І вона йде вздовж лісу, і вона йде від гір на перетині з Словаччиною і туди до Германії. І, власне, люди, які вміють їздити, ну, всі велосипедисти, вони можуть проїхати через всю країну на велосипеді, і вздовж цієї траси зроблені готелі, зроблені кампуси для зупинок, для відпочинку, для харчування, і вона тільки там в кількох місцях перетинає, ну, треба подивитися більш уважну карту, але вона не часто перетинає велику трасу, тобто там можна їхати взагалі не думаючи про автомобілі чи ще щось, якісь там небезпеки. Якби в нас в Україні щось таке існувало, ну, подібне, якась була така концепція, що можна було принаймні, ну добре, там не через всю країну, але через кілька областей проїхати велосипедом. І така курортна, це і курортна, і туристична, і оздоровча функція. Ідеально, це інфраструктура саме під велотрасу. Ну, так, я думаю, що ви знаєте цей приклад, він чудовий і він добре відомий в Європі. От, і я думаю, що тоді навіть люди, які дуже далекі від велотранспорту, тому що не було такої нагоди, захотіли б до цього долучитися. От. Так що бажаємо вам дуже успіху в цьому, і натхнення, і заснаги для боротьби у втіленні цього плану, тому що це дійсно дуже цікавий інфраструктурний план. Так. Колеги, у нас тут в чаті ще нові є повідомлення від наших експертів і від спікерів. Нам висилають Yes, Andrew, we see the links that you've sent us, and actually IPCC reports on climate change is the leading documents in our working group, because everybody finds something special for him in these documents. And thank you very much for your attention about that. And we will copy these links, and also we will try to implement that in our job. Does anybody have questions right now to the speakers? Hello, dear colleagues. No? Okay, then we will need a break maybe with all these presentations, and just try to keep everything in our mind and try to combine all the information. І дякую вам всім, що долучилися сьогодні, і ми будемо збирати всі дані, які лектори відправляють нам, на одну платформу, щоб ви мали до них доступ і змогли передивитися ще раз, і після цього зібрати певні вже додаткові запитання, які у вас з'являться, для того, щоб в подальших роботах наших секторальних груп було на що спиратися, і було також підґрунтя для подальших і висновків, і планів, і розробок, тому що у нас дуже багато чого має бути розроблено ближчим часом. Так що я всім дуже дякую, що ви долучилися, і сподіваємося на плідну співпрацю, на вашу участь в подальших вебінарах. So, thank you, dear experts, and we will hope to see you again in our future jobs and our webinars. Thank you for all the information that you provided, and see you next time. Okay. So, Efrat, are you with us? Okay. So, bye-bye. Thanks. Bye bye, dear friends.